add a comment or something like that. So when we look at the definition of a clean front-end architecture, one could be this one. It's a set of practices and principles aimed at creating maintainable and scalable and testable front-end code. So there are a lot of buzzwords in there. The main one would be maintainable and scalable, I would say. So in order to get there, there are some principles we have to follow. Here I've listed some of them. So there's the solid principle. I think all of you are familiar with that. Then there is the KISS, the keep it short and simple, don't repeat yourself, and so on. This is all concerning the code base, and then there are also some concerning the architecture, like the separation of concerns, component-based design, and domain-driven design. So it seems that it is not that hard to build a clean front-end architecture. I mean, we have all the principles, we just have to follow it. But most of the time, I would say, I've heard these sentences. So it says, we've started with clean code and clean architecture. However, now we have something that cannot be as easily maintained as before. Means at first, there is clean code. There is no problem with maintaining the code base, but over time, it isn't that maintainable anymore. So for that reason, I would like to give you some tips. So let's have a look at an example architecture that's just one example. Here we see that there are several components or several slices. So at first we see the API slice with services and data transfer objects. Then in the middle we have a store with actions and queries. And down there we have the domains or modules with smart and dumb components. So it seems pretty simple. But even with that architecture, some things can go wrong. Ich habe Keynote. Just okay. Sorry. Is it the next slide or? No, it's not.
So we never had Keynote before. Can you share your whole screen instead of
it is the whole screen. I mean, I can try it again. It says and if I do that, no, you cannot see it.
Can you just leave it in preview mode now?
But still in preview mode, he cannot see it.
Can you don't go full screen? But the preview mode is also full screen. Don't do full screen, and then probably it works. So maximize the window.
I mean, I can try that, yeah.
It works.
I mean, I have also a PDF. This works?
It works, yes.
Okay, then I will do it with the PDF. Okay. So I will move on. Even with that architecture, some things can go wrong. So if we have a look at the API slice, components may directly communicate with the service layer. Maybe there are stateful services that's and the store is not used, or think of like open API. So we have an API first approach. There's one YAML file which defines all the endpoints and the data transfer objects, and some developer wants to alter something, and instead of doing that in the one file, he does it directly. So this would be one violation. Or another one would be here, it says, actually we don't want to use the data transfer objects, and instead we want to use the front-end models. So we have a mapper here, and that's also a violation, or it could happen that someone just uses the data transfer object instead of the front-end modules. Or here we see there's a differentiation between smart components and dumb components. This can also be violated. Or even the domains could be too heavy. I mean, the logic inside the domains could be too heavy, or the components itself. So it seems that there are, even with this architecture, there are some implicit rules if you see the architecture, but developers may use it wrong. So the first tip would be to define some technical and domain rules. Just write it down, document it somewhere so that every developer knows how to use the architecture. One architecture I'm using quite a lot is the one that Manfred Steyer proposes. Here you see that it's sliced into different domains. So on the left side we have the order, then we have the offer, and then there's a shared slice. And within those slices, there's a layered architecture. Means we have a feature slice with all the smart components. Then there is a UI slice with all the dumb components. Then there is a domain layer with all the models, the store, and so on. And beneath that is the util layer. And as you can see from the arrow, only from top to down can be referenced. And in order to share something between those domains, we use an API. So there may be internal APIs for REST APIs, for example, and also external to share something. But that's not a silver bullet architecture. It just worked for my case. It's crucial to find your own technical and domain rules. And the next thing is that domain-driven design is a thing that also should be applied to front-end architecture. So every developer has to know the domain, and if he knows the domain, then it's easier to slice all the subdomains and build a maintainable architecture. So bounded context is one buzzword, and the other one is ubiquitous language within those domains. So every developer has to know all the terms within those domains. And there are two books, the blue one and the red one. I think all of you know them. Okay. I can do it without maximizing it. Yeah. Yeah. Okay, perfect. Then the next tip, you've seen that there are some implicit rules. I have given you the tip to write down all all the technical rules and the domain rules. And now we have to make it explicit so that no one can violate them. So there are module boundaries we can define. The most common way to do that is using NX. So in context of Angular, NX is like an extension to the Angular CLI to build a monorepo. And if you have a look at the left side, the architecture that I'm using, all the feature, UI, domains, and utils would be simple libraries. And there is one app that includes all the libraries. And the trick is to define tags within all these libraries. So we can say, okay, this library, the order feature, for example, it's in the domain order, and of which type it's of type feature. So there should only be smart components in there. And the other one, for example, is shared. It's the domain shared, and there should only be DOM components. And on the right side, you can see you can enforce those module boundaries. You can say, okay, in this case, type feature can reference DOM components and so on. But if you have a look at one beneath, type UI cannot reference the feature slice. And you can instantly see it in IntelliJ, for example, if you violate it. So that's an easy way to automatically enforce the boundaries. And now I would like to talk about the shared domain, because I've shown you this architecture, and there's a shared slice. And I mean, even in domain-driven design, there is the concept of the shared kernel, but I'm not a big fan of that. So my tip would be to either remove some layers within the shared domain, because I see no reason why there should be any smart component in there or any domain, because there shouldn't, in my opinion, there shouldn't be any domain or feature slices that should be shared. Or you could rename it. I mean, a little bit funny, but you can say, okay, you rename it to dumpster, for example, so that developers may not move components that easily over there, or you remove it at all. So in my case, I've just removed it. There is no shared, there's no shared domain, but that doesn't mean that there's nothing inside each domain. So let's move on. I've shown you that I've removed the shared domain. So I would say that code duplication is a thing in domain-driven design that's good, and it's the thing that prevents hard couplings between domains. So in my case, I would always choose code duplication over hard couplings between domains. So here you can see an example. So for example, we have a product. A product may be a different thing in different domains. It may have different attributes and so on. So I would not put it in a shared domain and share it with all the domains. I would say that each one of the domains has their own product. And just a little anecdote about that. We have implemented a software for one of our clients, and it all went fine. All were happy. And yeah, pretty excited. Yeah? and the product owner told us, yeah, perfect, everything went fine. So there is another user group that also wants to use it, but they have a slightly different approach, or they have slightly different requirements, but it's almost the same. So we have asked him further, and then we've seen, okay, in the backend it doesn't make sense to share something because there are too many differences, but actually in the front end it was quite the same at first. And in my head, I mean, I've learned that code duplication is something that's bad, and I was really struggling to just copy the code and move it in a different domain, because we have two user groups, so all the two user groups can have different feature requests. So it doesn't mean that if for the one user group it's good, that it's also good for the other one. So I've just copied everything, and I had a really hard time sleeping because of all the code duplication. But in the end, after some months, I've seen that there aren't that much things that are the same, because I always had to change something. And if I would have done it the other way, I would have a lot of ngIfs in there, and it wouldn't be maintainable. But as I've done it that way, that I've just copied it, it was easy to maintain and to change it. And yeah, that's FYI, that's also the same with strongly typed models, for example, or inheritance. I could tell you stories about inheritance where people thought they knew the domain, but in the end the customer wanted something different, and we had to refactor all of it. So it's never a good way to use inheritance. Always use composition. And the next thing about this architecture I would like to talk about is to use separate API slices. So what I'm talking about, here you see an example. So for example, we have different teams. So in this case, 3 teams. I have the one team from offer, that's the first domain. And it's an open host service, so it provides some APIs, for example, REST APIs or some components. And also other teams want to use it. I mean, at first it's a good approach, but you will see that there may be a lot of communication that is needed between those teams, especially if there are more than 2 or 3 teams involved. I mean, in the downstream, in the consumer part. So every time something has to be changed here in the offer, all of them have to communicate with each other. So, and yeah, a lot of time goes by. So in this case, I would always choose different API slices. So in this case, the team 2 has its own API slice, and team 3 also has its own API slice. And FYI, it's not a good idea if there isn't an upstream. So I've also seen it in some companies that there is a downstream, but there's no upstream. So you cannot change anything down here. And then there are some meetings where all the other teams complain about this team. Yeah, not a good idea. The next one would be to define, it's quite simple, to define ESLint rules. So I've shown you that you have to define your own architectural rules and you have to enforce them. And now it's more about the code. You have to make sure that the code looks the same. So something I don't want to have is that person 1 writes something or implements something, and I know exactly that's from him because of the code style. The code style should be the same. There should be rules defined, Yeah, and it makes it more easy to maintain. So what's a good approach? A good approach would be, so if you have a company or if you work in a company, that there is maybe a parent ESLint config that you can easily extend from. So that in the end, all the teams within a company use this ESLint rules, and then you can override some of them that you say, okay, this one, for example, on push strategy, this one is an error. And the main thing here is that you also have to integrate it in your CI/CD pipeline. So it doesn't make sense to define ESLint rules and don't do anything with that. I've seen teams that, for another anecdote, I have done some feature requests for another team, for one of our core teams, because they had a really struggle, and I said, okay, I have time, I can implement those features. It's and then I've just done a merge request, and I've seen, okay, they have others linting rules defined, and they didn't bother. They said, okay, it's fine. I mean, there were lots of errors. And they said, no, it's fine, you can just merge it. And that's not a good approach. So in this case, take it seriously if there are errors or warnings, or I mean, some warnings are not that bad and problem, but yeah. Yeah, and that brings me to the next thing. Take code reviews seriously. So if you have a clean architecture and a clean code base, it's so easy to get in the wrong direction. And the way to prevent that in the end is always during the code reviews. So if there is someone that doesn't follow the rules, or waits until someone is on holidays and then he can merge it. I've also seen that. So they said, okay, the one guy that has the explicit rules that he's on holiday, so we can merge everything. Yeah, okay, yeah, perfect. Yeah, but in the end, we have some rules defined. Both on the architecture side and on the code base side, so we have to follow them. It doesn't make sense if you just ignore them. And yeah, what would be some points during some code reviews? You can have a look at the best practices. So are there any errors, ESLint or errors or something like that? Are there any violations of the architectural rules? And is the code base clean? So can someone just easily maintain the changes? And yeah, the next thing is about dependencies. I have seen lots of developers who just add dependencies and actually don't know what exactly they are doing. So my tip would be to add additional dependencies very wisely. What do I mean with that? So I would start with the last one. I would always check if there is a way to implement it by myself. So if there is an easy way to implement that, for example, it's a one-liner, then I don't want to add some additional dependencies, because it's always a pain in the ass if you want to maintain a code base if you have too much dependencies. So that would be the first thing. Then I would say, okay, if you say, okay, that's not an easy task for me, I want to add an additional dependency, then have a look at the GitHub repo. and don't do any tricks. So I've seen it in several companies that they're just overwriting stuff. For example, that the library still works with newer Angular versions or something like that because it is not maintained anymore or something like that. Or they just create their own repo and fix it. I mean, it's also an approach, yeah. So yeah, also check. Is it updated regularly? Is it maintained regularly? Yeah. In this case, do your homeworks before you add some additional dependencies. Because in the end, I would like to have a clean architecture and a clean code, and I don't want to go through some code and always think, what the fuck? What happened there? And I have done code reviews and security reviews for several projects, and it's always the same. I always ask myself, why did they do that? Why did they use that architecture? It doesn't work. Or why is it not a clean code? Yeah. So here I've just summed it up. So my tips are to define all the implicit rules explicitly. So document your technical and domain rules. Use module boundaries to make it explicit and to make sure that it cannot that easily be violated. Then simplify the shared domain, because we have seen that everything can be moved to the shared domain. There's a trick. You can go around those technical and domain rules. You can just move everything to the shared domain. So I've seen teams that there are some domains, and the most heavy domain on the logic side is the shared domain. Yeah, it doesn't make sense if it's the shared domain. Therefore, just simplify it and choose the code duplication over hard couplings. So if you're not sure that it is really the same for two domains, then just copy it. It's always a better choice to just copy it, because otherwise it's not that easy to maintain afterwards if some other feature requests come in. And also use different API slices, define some ESLint rules, take code reviews seriously, and yeah, keep in mind that additional dependencies are bad. So that's it. Thanks for listening.
Let's do the question part. How many questions do you have? How many? 2, 3, 1 here. I give you the pancake flip. And in the meantime,
thank you. Regarding the shared components, isn't there the danger that people do the same work kind of like at the same time? Or let's say components that are used very frequently, like let's say accordion component, which should follow the design CI, CD of the company, and everybody's kind of like making their own. Like, how do you see about standardizing, let's say, UI components?
Yeah, that's a good point. Another anecdote, there were some bugs in two components that were shared over the whole company for each team. And our product owner said, oh my God, we have to instantly fix that. And I said, don't worry, we have our own component. So in this case, we already had some struggling with these components. So we chose to just move the code to our code base and maintain it on our own. And this was the better way or the better approach for us. But you're right.
One more question here.
Yeah, hello. I was late for the whole. Yeah. 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 Did you talk about testing or not? I don't think so.
No, I haven't talked about testing yet.
Yeah, I have a question. For example, consider that we want to write unit integration and end-to-end test. I can assume that you will keep the unit test in a module and end-to-end test in a project level. But what about the integration test? For example, if I want to test something which shares two modules, should I keep them in one module or in a project scope or something like that? And what is the whole idea about testing?
Yeah, in my case, what I'm doing is I always test all the stuff that includes business logic. So I do a lot of unit tests within the components, within the util classes, and in my case, there aren't so many cases where I would say it makes sense to make integration tests. I mean, in other companies, there may be a whole team for that tests the product. But if you have the case that you have integration tests, I would not put them in the domain or in the module itself. I would just put all the unit tests there. You can, put it on a higher level, so on the app side,
Can I ask a second question?
No.
Okay. You said that you will test your business logic. What about the domain? I mean that you will keep some models or entities. Do you also test them?
Good question. In this case, no, I don't, because I will always loosely define it. Means that I've all my domain objects are interfaces. I don't have any classes, so that I can easily maintain them and add new stuff or remove stuff. So in this case, I don't do tests for the domain.
Thank you.
1, 2, 3.
So, as I understand right, your conclusion about code duplication, that's right. Sometimes it's possible. So for me, it's strange because if you duplicate code and it's do the same, and if some changes, you have to think about, oh, I have to change it in two places, and lots of interesting situation. So, am I understand right that duplication is okay and not it better to make separate module or something for this code?
In my experience, it's better to just copy the code. I mean, if you have, for example, I don't know, 3, 4 teams that use the same stuff, then I wouldn't copy it. But if you have just 2 of them, I would always choose to just copy it. Even though it means that you have to fix it on 2 sides. So
Okay.
because of the maintainability, because often it happens that if the software is implemented and if the project is over, there are a lot of change requests, so in my experience. And in the end, these change requests always come with a lot of refactorings.
Any more questions?
In my opinion, so since we are also doing the same thing as doing, so moving some code into some shared own library, like inside library, like closed library. So as far as I see, this code application thing actually can be resolved by one another principle to find the boundaries and the components and the services and this kind of stuff should do as less as possible. So in my opinion, if you find your own boundaries, then you can avoid the code application. So
Yeah, sure.
It's if you shrink down what the component should do and maybe create multiple components that can do maybe some similar stuff, but they are like inheriting some properties from the other because they are like a wrapper component, then I think this code application can be avoided.
Yeah, you're right. Yeah. In the end, if you slice it really good, then you can avoid the code duplication.
Okay, I just wanted to be smart. Thank you.
My question is. Yes, thank you. My question is, what if the project is already huge and the standard is not set and it's pretty much all the mess? So how to start to clean up when I need to do my day-to-day work and I don't have all the time just to refactor it?
Yeah, good question. Yeah. So defining all the architecture rules and something like that is always crucial when you start a project. But if you have already done that and the project is over, it's pretty hard to do that. I would recommend to start slowly so you can move some parts, but not the whole project. So in this case, maybe some other approach may be helpful. So you may do event storming so that every developer knows exactly the domain. And if every developer knows the domain exactly, you can easily slice it, I would say, and then do it piece by piece.
Okay, thank you.
Yeah, so you didn't mention the favorite part of every single coder that I know, documentation. So I know that every single coder loves writing documentation. So can you give like a quick tip or I don't know, tool or something to quickly create and easily maintain documentation? Because I believe it also helps to keep the architecture clean.
I mean, I wouldn't document anything in Confluent because it is, in 1 year later, it's out of date. So I always do it like that I document the code itself. So, I mean, it's the definition of clean code that you easily can follow the logic or everything that's implemented. And if there is something missing, then you just add a comment. So that's the documentation I would prefer. But all the others didn't work for me.
Okay, thanks.
Perfect. Round of applause. And now we have a very quick switching the stage break, 5 minutes, then we do the next part, then there is pizza. So if you just Okay. I would say let's just kick it off, even if the camera is not fully working. Welcome back from the short break. We switched a little bit the agenda, and now we will talk about how imports can hurt your bundle size, your speed, your user experience. Another how to say regular speaker here on our Angular Meetup stage. Let's welcome with a very warm applause Vojtech Mašek.
Show it in. So, share screen, hide, this, slideshow. Good? I'm not sharing? Okay, let's do it again. Let's do it again.
But there's Alex.
This, share, here, here.
Fair.
Beautiful.
Press it like that. Oh.
Is it solved? Yeah. Good. Thanks for introduction. And the question is, can imports hurt your build and speed size? And the short answer is yes. And the long answer is 25 slides long, so we can get to it shortly. I'm Vojtech Mašek. I'm speaker, I'm GD for Angular, and I also organize a meetup in Brno, which is a city very close in Czech Republic, like second largest city there. Have you ever been to Brno? You should. Yeah, Brno is great. It's like a cheaper version of Prague without tourists. No tourist trap, it's amazing. It's like, Michael really likes it there. He goes regularly. So, yeah, and we organize a meetup there about Angular and about beer, and we take both very seriously. So it's usually a very good, very long meetup with karaoke at the end, so pretty similar with what you have there. But with actually, like beer pipe, keg, not like a bottle, so cans, like proper beer, Czech Republic. So let's get to the Angular part, or to the JavaScript, TypeScript, because I will not be talking that much about the Angular, to be honest. It is not specific to Angular. This topic is specific to JavaScript and TypeScript ecosystem. So let's start with a little bit of history. It will be a short quiz, and you will see pictures, and feel free to, try to tell me an answer, and whoever guesses right will get the token for the raffle. Damn. Let's pretend it never happened. So let's have a different kind of quiz. So do you know what this is? What this is? COVID? No, it's swine flu. Who is this? Barack Obama. True. Bitcoin. Okay. This person also is pretty famous, and he died in that year, so it was pretty sad year all along. There was also some other things that happened. For example, this plane landing on the Hudson River, brutal ground shaking. What is it called? Earthquake. Thank you. In Italy, it was not good. And why I have this is because of the year. So who saw it can shout it now. What year is it? Yes. And in this year, now actual question. What happened in this year? Besides all these things? Something important. What? Angular?
No.
Nah. What was it?
Launch.
No. TypeScript, no. Imports. Good thinking. You are close. You are close. So, CommonJS happened. CommonJS happened. It was developed in that year, and it got very popular with Node.js. And with imports, you were very close, because this is actually the time that
some specific keywords were introduced. So a special variable called exports actually happened in this year with CommonJS. Before that, it was not really. There was not a simple way how you can export code, so we can do imports, so we can, do all the domain-specific code organization. Not possible in JavaScript. Like before this year, before CommonJS, you just had, a huge file and you were happy with it. And there was also this special function called require, because when you export, you also maybe want to require. So this all happened in that year. And now we get to how the CommonJS itself works. Does everybody know what CommonJS is? Like how deep I need to go? So we are all using it probably to this day, even though you shouldn't. We get to that at the end. Let's see how it works. So it's the classic JavaScript thing where you have all the requires and exports, and how you can already tell the file that you are mentioning in the require function is required. And what does it mean that it is required? It means that it will execute, and the exports are synchronously waiting until the file is there. So in theory, if the file is not there, your code will do what? It will wait for it forever. Like it will synchronously wait. Maybe now there are implementations that will time out eventually. But back then it would just wait for the file to be there. Why would it do that? Because it was designed for server side. It was designed for running JavaScript on a server. And fun fact, it was even called server.js. So it was not called CommonJS or something like that. It was called server.js back then. And everything you did, you were just expecting things to be there locally. That's how it was designed. And it was later picked up by browsers and somehow, started to work. And that was just because the require, as I already said, was a blocking operation. So in browser, eventually, whenever you would require something, the request would be made to the server and it would block the execution going forward. That's how it worked. To this day, some of these websites are, selling you flight tickets and, I don't know, taking your healthcare information. So it works still, but it's not ideal. And why is it not ideal? Because we have better things, to use now. We have ESM, and overall, it is not designed for browsers. So we get into whys later. I will not do the same mistake again. So here you have a beautiful quiz of what happened in this another year. Can anyone guess any of the images? This one is the easiest. What? Hub? Oh, no, it's not Hub. Horizon? It has something to do with a planet that was not really a planet. So they discovered that Pluto is not a planet. And yeah, then there was this German pilot who decided to, crash into the Alps. So overall, very interesting year. FIFA was shown as a very corrupt organization, interestingly. What else happened is obvious, or I will ask that. Do you know what else happened, or what year it is? Maybe let's start with the year. 15? 15. Very good guess. 15. It is 15. So what happened in 15?
Imports.
Import. You are very close. Very close. What exactly happened? Webpack? No. So it's 15. ESM happened. ESM itself. So this is the year where we got the ES6 naming, and this is the year where we actually got the ESM as a standard of ECMAScript modules. Before 2015, we had nothing. Before 2015, we had the CommonJS, and it was not good. So ECMAScript modules got introduced. That doesn't mean that everybody started using them. They were introduced. The import and export top-level keywords were added to JavaScript. So from this point, you could not name something import or export. Before that, you could. So now you cannot. This is how we see TypeScript now. So this is very closely related because TypeScript actually decided to use import-export before ESM was even standardized. So we can be thankful that they didn't decide to use some else, like some different keywords, because that would be horrible. It was designed from scratch to work in browsers and asynchronously. And we'll explain that later, like how. So full ESM support only landed in Node.js, in Node 20 in 2020. So it's pretty recent. Like you can probably imagine that it really got hyped to that much that we only have like 4 years of actually having that available in Node. So you can imagine, how not available it was in browsers 2 years ago with Safari or other things. But now we live in a world where there should be no reason to not use ESM. And we can explain how it works, because it works a little bit differently. There are these subtle differences which actually make it horrible for JavaScript developers to live and use both of them. Internally, it uses top-level await to do all of the imports. Do you know what top-level await is? So it's like when you do await in like asynchronous functions in JavaScript, but on a top level, not async function, but outside of the scope of any function or class or whatever. That's how every import is internally evaluated. When you write import, you can basically, like behind the scenes, there is await import. It comes with dynamic import. Why? Because all imports already work in the way where they are basically somehow internally, promise-like. And with dynamic import, you can dynamically import stuff. You can do it on runtime, conditionally. It's really fun. If you never use dynamic import, give it a try. It's great for runtime or performance, like bundle size optimizations, because you can really slice things out and be sure that they only execute when they are needed. So all imports only execute once. This is pretty important. Like with this sentence, we will move on to many code examples and whatever, and you have to remember ESM executes once. Every time you put import somewhere, that import is executed, and it will never be done again. In the same context, of course. There is an interoperability problem in the JavaScript ecosystem. We can call it the biggest divide of the JavaScript community. So the biggest divide itself is the divide between should I use CommonJS, should I use ESM? Why? Because of obvious problems that we touch on later. With ESM, you can safely import CommonJS, it's fine. Somehow you can do it. But once you import CommonJS with require, then you can no longer import ESM again. So it's complicated. With CommonJS, you can import ESM, but only if you wrap it with dynamic import or equivalent functionality. Again, very weird thing to do and to remember when you are actually using both combined. And when you are already using both combined, you also need to take care of one more thing, and that is dual package hazard. Because you can import both at the same time. You can, import library that has both implementations with similar looking syntaxes, and suddenly it's twice in your code base. And then you can think of it like, maybe it's a chart library, and I use some global configs for that chart library, so it, I don't know, does something by default, and suddenly this config, doesn't work when I import it differently somewhere else, because it's a completely different library from the perspective of bundler. It doesn't know that it's the same package. It's yeah, very, very hard bug to debug, very hard bug to realize it's happening. People don't usually check the imports first, and even if they do, most of them don't understand that, like from that context, it could be so breaking. Never mix requires and imports in your code. Like if you have, for example, same code, same file where you can see require and dynamic import, it may be source of some problems that you don't realize you have. So compilers play very huge role in what you are using. Do you know what you are using? Do you know what, like, if you are right now in Angular using CommonJS or ESM? Who knows for sure?
Mostly ESM.
Mostly ESM. Why?
Because it's asynchronous.
Which bundler do you use for Angular? There are two currently. It depends. Oh. So does everyone know that Angular currently has two bundlers? One is Webpack, one is ESM or ESBuild. Obviously, ESBuild uses ESM. Does Webpack one use ESM? You can easily check it. It depends on the version, of course. You can easily check it. Check your output. If you see require in that output, you are not using ESM. So it's that easy to check. But I think it's Angular 9 plus, you are using ESM, no matter what. It's when the dynamic, how was it called? The polyfills double loading thing was introduced, the conditional polyfill, something like that. From that point, you are using ESM. So, or old browsers are using CommonJS, of course, but new ones are not. So, with ESM, it is slower for larger apps. And I don't mean slower in build, I mean slower in execution or in first start, in the initialization. Why is it? So, the entire module graph needs to be loaded when using the whatever you are trying to import, or awaiting the import when it's dynamic. So the whole module graph needs to be constructed at that point of time. What does it mean, simply put? The module graph is everything that you can get to from the point you are importing a file to, whatever that file imports, that file imports, that file imports, up until to the end where there are the actual statements and exports. So this is the module graph. Everything is jumped, like in a network when you have to go from router to router. You do this with importing files. Every time you mention a file somewhere, you are importing it. The Webpack itself is file-based import. The ESM is also file-based import. It will do it like that. It will jump from one end to the other and see everything. Everything is visited. We will see examples later. Even if if you wrap the package with dynamic import, it basically returns a promise. And this promise is later on, awaited and only executed once, as I said. So every time you do dynamic import something, like the same library, it will never be dynamically imported again. It will just reuse the same thing again and again. It's not an actual promise that would, fire again. It just looks like that. And the most important thing is that if you really understand how ESM works internally, you will realize it's slower by design. They actually made it like that to be slower. They are trying to work on it to actually enable some of the features that you would normally have with require or with CommonJS. So it's not that slow, like obviously, but we can explain why is it. So it's two passes are needed to bind imports to exports. What does it mean, that two passes? Like if you have a file and there is something written, something exported, and then actually imports are evaluated, it will go through this 2 times. In CommonJS, it would just do it once and hope something is out there. In ESM, it needs to be sure that thing you are importing is there. If it's not, it will not build. You will have to do a real magic in configuration to actually, tell it, please ignore this library because I built it elsewhere, and I will provide it to you as a like minified JavaScript. So you will really have to make sure that compiler knows things are there. The entire graph, as I already said, needs to be parsed and analyzed. So it will not do that only for the top imports. It needs to know that everything you are doing in the whole chains is actually correct. Even in the libraries you are using, it needs to be sure that the thing the library is importing actually exists. So the whole graph is parsed and analyzed. And then, only then, the code is evaluated, only then everything is correctly put together, and only then compile actually, not compile, the executor in the browser or in Node.js actually does something. This split of first parsing it and making sure, and then doing the rest, is actually what makes a feature that is called live bindings possible. I didn't know before researching this what live bindings are. Does anybody already know what live bindings are? No, beautiful. So we will have a little bit of fun. We have 2 pieces of code on one side. But wait, it's okay. So left side is ESM, and the right side is CommonJS. And it's basically the same code written twice in different syntaxes of export. And what I'm about to ask you is, what are the outputs of these pieces of JavaScript? What does the CommonJS output and what does the ESM output? Who wants to give it a try? And those ones who know, because they've seen the presentation, should not answer. If you cannot see it, it's simple. It's exporting variable count that is 1, then having an increment function which does the prefix incrementing, and then actual console logging of the count, incrementing, again console logging. So I'm looking for 2 numbers. What will be the 2 numbers outputted here and 2 numbers outputted here? 1, 2, on which side? Both? Left side. 1, 2, and here 1, 1? Okay, so 1, 2, and 1, 1 is one guess. Is there any other guess? 2, 2 on both sides? Okay. So let's see the answer. It's 1, 2 on ESM and 1, 1 on CommonJS. So what did I do? Did I break it completely? No. It works. Good. So why is it? Why is it that ESM will actually output 1, 2 and CommonJS 1, 1? So the simplest answer is memory. If you look at it and try to come up with the reasoning, you can say, is this count here actually the same as this count here? This is where you get 1, 1. So no, it's not. This is you are assigning a value here to another variable that you are exporting. So it can never increment this, obviously. If you look at it from this perspective, it has nothing to do with anything else. It's just the memory thing. But this is actually what makes it possible in the ESM, because you are directly exposing this part of the module outside, and you can do whatever to it. You know, if it's not a const, if it's let, you can increment it, and this can be interesting if you need that feature. I don't think it's a good pattern. I don't think you should actually start using it or have it this way. But there are, let's say, if you know some like things that check your performance and have some arbitrary timings somewhere saved and then re-export it. It can be pretty useful for very specific libraries, or for some kind of seed to be exported to multiple and then increment it. Very niche requirements, but it can be useful. So these are the live bindings. Let's go there. If we forget about all the problems that ESM and CommonJS has, we can think of a bun. Have you heard of bun? So bun is a beautiful thing. Why is it beautiful? Because they actually fix this problem. They don't have this problem in bun. They support both ESM and CommonJS at the same time. There are no problems between import and export. You can use whatever you like. And if you ask how, the answer is simple, because they are completely ignoring the spec. Like, they do not follow the spec. They just do it themselves, in their way, completely re-implement it and just interpret it as it should work. So in ideal world, it would be done like that. But since JavaScript actually implements some of the specs and follows it and supports it for a long time, it doesn't work like that. Never mind. We can use bun in future. For example, I've seen that in NX 19.5 actually supports bun as a package manager, and I also think it also supports it for runtime. Instead of writing npx, you can write bun execute or something, and it's pretty nice. We can get there soon enough, I would say, another 4 years, and we don't have this problem. So the import system just works. Let's end with that. Now that we are out of the basics and how the systems of imports work, there is a question: should I use bundler if I have ESM now? Like, I could just use ESM. I would type or refactor all my code base to have MJS instead of just JS. I would do dynamic imports everywhere, so I would take care of everything manually. Do I need bundler? Do we need bundler in Angular? Can we just use ESM for it? Why would we use ESBuild or Webpack or Rollup or whatever? Well, so answer is simpler. Again, loading speed actually matters, and the loading speed, if bundling, is much better if you actually do it correctly. So the import and export syntax is analyzable. You can tell, the bundler can actually tell you pretty easily if you are doing something wrong. There is static analysis available. It's much faster than finding out in the build process itself. Bundles actually optimize code, so you don't have to take care of these things manually. Otherwise, you would have to manually, take care of each of the unused code in your whole application. Bundlers do that for you mostly. Yeah, they are just eliminating using multiple strategies. Code tree shaking be one of them. I have a whole another hour-long talk about it, so let's not go there. And we can always ask, what would Chrome team do? So they would recommend you to still keep using bundlers, at least for the production builds. And this is why this simpler, small not that readable graph. First one is unbundled. So blue, or I don't know what the color is, I'm colorblind actually. So this part is idling, this one is Blink engine, this one is V8 actually running your code. So this is what happens if you have a application that has library of around 300 modules. It runs the whole, till you get to the end of execution, 200 milliseconds. Just that. If you actually don't bundle, but have module preloads, so eliminate the time it gets to download the things, you are 170 milliseconds. If you bundle and not optimize, do not tree shake, still have unused code, still have things that you don't really need, you are at what? At 70, 80 milliseconds. And if you bundle and optimize, you are under 50. This is an example benchmark where they actually tested of how an application normally looks and included these 4 steps, checking how long does it take to actually execute the whole code. Just based on this, I would say, keep on using it. Even from my own experience, I would say, do not ditch the ES-Build or Webpack. Just be glad that any post-processing is actually happening because your application is actually usable thanks to it. Now we are getting to a topic I also included because it's closely related, bearer files. Do you know what bearer files are? Index.ts, yes. Index.tx, index.js. Do you have these files in your code base? A lot of them? Not a lot? Did you already find out? Okay, some of you did. So they actually cause problems. And what problems do they cause? I think we will have 2 separate problems, so let's get to it. We have this code. So on one side, there is a bearer file, and on the other side, there is something that we will call stacked imports. Yeah. So if you re-export things like that from your library, you are using bearer files. It actually doesn't have to be called index. It can be called whatever. Index is just something that will provide you the feature that you don't have to write the name of the file because it just takes the name of the folder. But you can name it whatever. You can call it, public API.js and then re-export things. This is also a common pattern in libraries. So 2 approaches. The problem itself. Tools are very slow if you have a lot of bearer files, and I will explain why. It has an impact on the size. Like suddenly you are in an environment where whatever you do, whatever you add actually matters, and you are just letting the bundler, as I already explained what bundler is, you are just letting the bundler do more and more assumptions about your code. Because you are grouping things together based on what you are assuming they should be, but you are not really thinking of is this actually used and imported together? Do I need, this pipe with this button? Why they are in the same library? So they have the bundle size impact, and again, there will be separate slide on it. And it's a lot of boilerplate. Like you probably already been in a situation where you change something and then it doesn't work because you didn't change it in some folder somewhere where it's re-exported, and some people re-export it way far in a completely different galaxy. Suddenly it's a different NX library and it re-exports something from the root. It can happen. Some people do that, and what also does that? IDEs, when you move things around, they tend to change and keep the refactorings in a way where it goes through the code review somehow, and suddenly you are not following your module boundaries. So there is an impact. There is a common misconception where people think that modules load only when they are needed. That's not true. Every import is loaded, parsed, and executed. Once you do import in your code, it will be loaded, parsed, and executed. As I said, that's how things work. There is, nothing like this import will suddenly disappear. No, it would only disappear if everything in that import is 100% unused, 100% side effect free, and not needed at all, which is a rare case. That's only when you really take good care of your libraries. So there is a thing called execution order. That's why it cannot just disappear. That is a thing why it cannot just skip some things, because if you do this, you have a feature A that has a global this foo 1, 2, 3. Then you have a feature B that has a console log of that global this foo. And you have a feature C which just exports letter X with assigned value of 42. Then you have a barrel file with just ABC re-exporting. And then you have a main.js which just imports the X from the barrel file and logs it. What is the output of this one console log? Or not one console log, what is output of this main.js? Like if I execute this, what do I get? Again, 1, 2, 3, 4, and 42. Exactly, yeah. You will get 1, 2, 3, 4, 42. And why is it? Well, because execution order. What the interpretation or execution does is, seeing the X and being like, it's from feature. What is feature? Feature is this folder, but it has index. So let's have a look. A, parsed, execute. A, assign to global this. B, log it. C, X, get it here, log it again. This is what will happen. If this would not happen, then things like prototype changing of, I don't know how RxJS used to work or many other libraries work to this day wouldn't be possible. Then global constants wouldn't be possible. You could not create things like polyfills. It wouldn't be possible. So it has to be done like this. Everything is visited, everything is executed. Once you have a simple console log somewhere, it's executed. Once you have a piece of code that steals your npm credentials, it's executed. Once you do that import. Once your library does that import, it's executed. You cannot do anything about it. Only way how it wouldn't be executed if it wasn't actually called and if the whole file was like completely stripped away by tree shaking, which can happen pretty easily, but only in small projects. Like if you have small projects, that's usually what people do to set up and verify what is happening. They have a simple project, just put few things there, and they are like, my bundle is in perfect condition. Like it cannot get any better. Why? Because it ran for 3 seconds and it got, to the best condition it could get mathematically. If you have a huge Angular project, chances are you are never getting with your bundle to a most perfect condition because it will just output something after a while. Only see it when you have unused import and you need to delete it or something. So keep doing it, don't care about it. What is important of how many files along the way you need to visit. So if you get rid of the bare files, you are helping your own code readability, you are helping the bundler, and you are also helping the execution context so it doesn't need to do many things. And when we get to the effect on performance, I like to include a little bit of numbers. So there is an experiment. Experiment is 100 test files. And these test files actually run in 4 parallel test runs. And you can see how the time adds up after more and more modules are added when these 4 workers are actually used. So this is an excellent example of how your jest is executing your test, or how your ESLint is running your lint rules in parallel, or how your Cypress is doing things. So when you have 500, it's fine. You know, what is 3 seconds? Also, this is not how long tests run. This is how long test runs plus overhead of what the graph was doing, like what it took to construct the whole import graph. So take that in mind. It's probably like, you know, minutes of test plus 3 seconds. So plus 3 seconds, then plus 7 something. Suddenly it's minutes or minute. Suddenly on 25,000 it's 7 minutes, and on 50,000 it's 20 minutes of overhead. Of how long will your ESLint run of overhead, not the actual execution of ESLint. Why is it? Well, because each of these workers is creating its own module graph. And everyone you add, sorry, I will be very quick now. So every one worker you add, you are creating one more module graph. It's horrible. This is why your tools are slow. This is it. If it starts like if you are in a project of 50,000 jumps that need to be made through the files, you are looking at this. That's why your jest takes over in CI with 6 parallel workers. Effect on bundle size. Of course there is. They are known to cause optimization bailouts. This is a quote from Angular team. I think in comments somewhere I have the issue. Your lib application, it will, you know, from the graph theory of mathematics, it will try to get you to the best output in a given time. It doesn't want to run for 6 hours. It wants to run for 8 minutes. You want it to run for 8 minutes. It will output something after these arbitrary assumptions are made. Any common jest is not reshaken. Remember that. What are conclusions? Some Barrow files are fine. If you have tens of them, if you just export, you know, really some public API somewhere, you know, keep doing that. Once you have Barrow file in every folder, you are doing something horribly wrong. If they serve for API restriction, it's good, but you can also use the enforce module boundaries, and you can actually start using the NX in a way where you name things properly. Like there should not be a library called design system. That's multiple libraries, of course. Like not all design systems should be exported as one thing in a Barrow file. That's not how it's supposed to be designed. Executive use, you know, very serious slowdowns. Huge projects can be very affected. Test runners, linters, everything like that, especially. Final conclusions: bundle your apps. Don't ditch the bundlers. You know, give it a good analysis once it's output something. Every new project is ESM project, and ditch the Barrow files mostly. You know, start deleting them, ideally, and sort your imports. That's the least you can do. Everyone should sort their imports. This is a prettier RC plugin. You can have the presentation, copy whatever I put there. Even the little snippets of codes are also available in Code Panel somewhere, so you can run them, see what it's doing. It's fun. Thank you.
Even if the pizza is ready, we can ask a couple of questions. There was the first hand up, then the second one here, the third, fourth, fifth, maybe sixth. Let's see. Let's go.
Okay, I've presented an architecture, the presentation before that. And with that architecture, you will have a lot of libraries. So there are many slices. Is it better to have less libraries also? Because all the libraries have a public API inside.
Yeah. So, how I like to structure my libraries is if they don't need the public API, like if anyway I'm able to import everything from the library separately, then I tend to actually expose the things with the asterisks, like in the annex, and you know, let every pipe be possibly imported by its own folder or its own thing, its own file. Also, if you absolutely need to control the public API, what I a little bit skipped that, but what I try to say is that you can decide what is your public domain and expose it, or you can decide what is your private domain and hide it. And I like the private domain approach much more. So what I would do, if there is private things in the library, I would hide it into private folder, and I would, with the boundaries configuration, not let you import it. Only the library itself should be able to import from its private folder, no one else. So you can already set up the ESLint rule like this. And that also extends to other things, like if you start using the names of the libraries correctly, so they correspond of how they should be imported. It's very easy even for like when it tells you in the lint rule like something should not be done this way, then it's very easy for you to spot it. It's because I'm importing something that is not meant to be outside of this library. Do I need to extract or not? So I would try to avoid the index TS file, because once you have 100 libraries, it can already start making this impact where many things are taken into consideration by bundler. But on the other hand, if you are trying to control the public API and you really have this option and just use the index file there, and you have 10 or 100 or 500 of them. Well, 500 are meant the hops, so 100. It's good. Don't refactor that.
Okay, thank you.
Thank you. Next question, quickly. Here we go. And your number.
So my question would be a bit more Angular specific. So with all these index.js and whatever we can. So I also saw that people are just, whenever they're creating a service, it's usually automatically created with provided in root. So whenever somebody is creating like a library and whatever, and then they're providing the services in root, I'm always questioning. It's just maybe just my understanding is lacking of knowledge. But is it then tree-shakeable at all, or is it basically?
That means it's tree-shakeable by default, because once it's not referenced as a class anywhere in the code, or if it's only let's say you create a service for some specific component that is like way back in your admin side of the whole application, where users cannot really get. They will never load that piece of service, because if you provide it in root, it basically means that there is no actual reference somewhere in the code. Previously, you would have to have it provided in providers, and that already couples the service file with the module file, so they would live together. Everything you would mention in the module as a service would live in that module chunk, and that's now not happening. So with standalone and with provided in root, you can basically get every component its own file. It's not ideal. If you have a huge application and if your initial load depends on many things to be there, suddenly there could be this waterfall of loading things. So there are also ways how to overcome that. But in ideal world, in ideal HTTP3 situation, or maybe even beyond that, you would want everything to load separately.
2 more questions, if you're fast.
Yep. What about type imports? So I've heard that you can use this import type syntax.
Yes.
Is this beneficial? Can you elaborate
Very beneficial. Every time you can do that. Even, especially, for example, with the dynamic imports, you are dynamically importing some kind of library to an highlight.js example. Yeah, you want to dynamically highlight piece of code for some embedded component dynamically, but you also want to have the types of highlight.js. You don't want to just, sometimes you need to pass options somewhere or whatever. So what you do is do import type highlight.js, then you have the type. You can use it anywhere. You don't have to be any worries. It will never import the actual piece of code. It will only import types or infer types, and then you are fine. And with the newest syntax, you can also include the type annotation inside of the curly braces. So you can also don't just do import type curly, but you can do import curly and then separate things. It's just types.
Last one.
I have a question related to that live binding thing that you said.
I need it a little bit louder.
Yeah, about the live binding thing that you said.
Yeah.
I know that in ESM we have modular scope, and I want to know what is the relationship between these live binding and the closure concept, and is it related to shakeable or not, and what is the situation in CommonJS?
So relationship between ESM modules and what? And
closure concept and live binding.
closure concept. Ah, okay. Phew, very good question. I don't think I'm qualified to explain closure. No, really. There is not a huge relationship between that. One is import system and other is context execution. And in that sense, you would already have to have everything for closure to be needed, imported. Only difference, like if you are asking about closure in context of evaluation of, like if you do dynamic import and then the closure of that, like then something, then everything is provided in context of that own promise. Did I answer, or maybe we can talk about it? I'm not really sure.
Pizza, and here is outside. Grab it, it's already getting cold. Läuft. Welcome back, everyone. I hope you enjoyed the pizza. I hope you enjoyed the beer, plural. And I hope you have energy left for the next 2 talks. Let me pitch the first one. I'm pretty excited. Next one is from Matěj. Look at this handsome gentleman. He's talking about managing tech debt in Angular. But let me tell you why I'm so massively excited. He will show you the very first product that push-based in cooperation with Flob is shipping. It's a conformance tool, I would call it, but I don't want to spoil too much. Let's welcome on stage with a massive applause, Matěj Chalk.
Okay, so hi, my name is Matěj Chalk. I work at a Czech company called Flop. It's actually the same company that Vojtech works at. I work there as a tech lead and a full stack engineer. And today I want to talk to you about managing technical debt in Angular applications. So technical debt is probably a term you've heard of, even though it's sort of it means a lot of things. It encompasses sort of a general sort of pain point you tend to know about in a code base. The definition of something is something like when you're prioritizing delivery speed, then you take a lot of shortcuts along the way. Instead of doing it right, you try to go fast, and in the end, that debt accumulates and you pay it back with interest, usually. But also different people tend to see it in different ways, particularly people in non-technical roles have their own understanding of what technical debt is, but it's a very broad topic in general. It's also a very important topic. There's actually a recent Stack Overflow survey with some pretty scary results about developer happiness in their jobs. It says only 20% of developers are happy with their jobs, apparently. And one of the most common causes of frustration that they cite, that 60% talked about technical debt. So it's a big problem for your project health, but also because it's kind of vague, it's difficult to measure it and put your finger on it. In practice, it's more based on your senior developers having some insight into a code base, knowing some context, and it's sort of based on their know-how instead of some objective metric. Now, this is a bit of a problem when you're trying to get buy-in from your management to take an interest in tech debt and allocate some budget for it. It tends to create a bit of tension between your developers who really want to prioritize it and your managers who don't really understand it and they don't really see the value in it quite often. Because for them, it's basically kind of invisible. It's behind the scenes stuff. They maybe understand, oh, it's slowing us down, but they don't know how to fix that. They don't really, the effects are just too indirect for them to see. And this is a problem because what the management and businesses in general like to plan around is some sort of KPI, some sort of measurable metric that I can just say, this is our goal, and we can tell if we're improving or not. When we don't have that, then we have some common ways of managing tech debt. One of the less efficient ones is every now and again we plan a big maintenance sprint where we'll clean everything up, we won't work on new features. Super unpopular with our managers because from their perspective, nothing's happening, work just stopped. They don't see the impact. If it's not very well planned, it can actually be also difficult for developers to see the impact and evaluate it. When you're doing a big refactor every now and again, you tend to have to plan it very specifically to use that time properly. And in general, these things are often just done too late. A much better approach is what's called the Boy Scout rule. The idea is that instead of just doing a big cleanup every now and again, we make that part of our daily tasks. So whenever we're building a new feature or we're touching some existing feature, we're making some modifications, we always want to leave that code in a better state than we found it in. So even though some of the old code, which we're not touching, has some anti-patterns, we don't make those same mistakes when we're building the new features. That's quite practical. One of the downsides here is it sort of puts the burden on the development team. We tend to have a lot of proactivity about this, and just developers sort of having this value of doing the right thing, because again, it's sort of behind the scenes work that the managers don't see. They don't tend to reward it very much because they, again, don't see these effects. If not everyone in your team is on the same page, then that can be also quite frustrating. It also can be a cause of burnout as well. So what I'm going to propose in this talk is a solution, and basically to solve the metric problem, making this broad, vague topic of technicality, reducing it to some sort of number or few numbers that you can actually use to communicate with your project managers, and then for them, suddenly it stopped being invisible. It's something they can track, they can show it to their bosses, they can actually measure, this actually improved, and I have the numbers to show it. I have some progress chart that I can refer to. Even if they don't actually have a deep understanding of what that is, it's actually funny how effective that is. When they see numbers, when they see charts, they feel like everything's under control, and they can pitch it. So how do we solve this problem of quantifying technical quality? Because it is so broad, it isn't an obvious solution. We have a lot of sort of partial solutions. There are various tools out there. A lot of them you know, they're part of your usual developer workflow very often. And they measure quality, but in just a very specific aspect. So for example, we have various static analysis tools. One of them is, for example, ESLint, which was already mentioned, and other linters for CSS or TypeScript itself is actually, you can think of it as a sort of linter just focused on type checking. We're just evaluating the source code. When we find problems, the advantage is that they're quite, they sort of point you exactly to where you should fix it very often, but they're not running your application. So it limits the types of things they can measure. We also have testing, whether that be unit tests with Jest or vtest, or also end-to-end tests on the sort of other end of the scale, which is Cypress or Playwright. There we have two key metrics. One is code coverage, giving us some indication of how much of our code is actually being tested, and also the test results themselves, whether they passed or not. For unit tests, that's sort of pretty obvious. You don't merge if you don't, unit tests don't pass. But with your end-to-end test, that's easier said than done sometimes. They tend to have a big flakiness problem, that they're not very reliable, and it's useful to keep track of if you're breaking your end-to-end tests. Also, in modern applications, it's not just our own code. We have a ton of different third-party dependencies. It's important to update those to future-proof your code. And also, there are known vulnerabilities listed for these third-party packages, and it's good to also do a security audit so that you know about these vulnerabilities and you can update and avoid shipping those exploits to your users. And finally, from more of a sort of black box outside perspective, we have tools like Lighthouse, which is sort of the comprehensive web application metrics like best practices, performance testing, accessibility checks, all of this stuff. Also specifically, the topic Vojtech is very interested in is bundle size, which is sort of a subset of performance, specifically about load time performance, which is based on whatever bundler that you're using. A bunch of other examples I could give here, but these are just the ones I'll talk about in this talk. Okay, I'll try. What these tools have in common is that they're built that you run them on your whole code base to understand what the problems are and what the measurements are. They're not really set up to continually track progress. If you're doing slight improvements, it's just sort of checking the state all at once. Typically, you just add those to your continuous integration pipelines. But when it's something that's hard to actually achieve, some lint rule that you're introducing later on, and you're not going to be able to fix everything at once for a big code base that's very realistic, then you can't just add a CI check because it would fail and you can't fix it immediately, you have to do it later. And this requires a bit of creativity when you have tools like this. What you really need when these sort of big legacy code bases, you need these sort of long-term efforts, big refactors which could take weeks or months. You're migrating to some different testing framework, you're introducing a design system, and you can only do that gradually. It's really useful to have some sort of a tool which is actually tracking your progress and telling you if you're getting closer to reaching your goal. And for this reason, we built a tool called Code Push-Up, which I'm going to be talking about in the second half of this presentation. The idea is we take all of these different useful quality tools and we merge them into one comprehensive report so we get the full picture. And we also track your reports and see how the quality is changing over time. But first I'm going to talk about how these tools and how you can best use them. Start with ESLint. I'm sure you all know it. Static analysis for JavaScript or anything that's built on top of JavaScript. Really good at enforcing code consistency and looking at some common anti-patterns, some common sources of bugs. It's also completely pluggable, so typically you don't just use the core rule set, but you have various plugins. For example, if you're using TypeScript and Angular, you have plugins with specific rules about those frameworks. A lot of plugins it's a really big ecosystem, actually. And if you don't find the rule you're looking for, you can always also implement your own. Big convenience is that a lot of the rules are auto-fixable, or at least you get suggestions in your IDE. Not all of the rules, but for a lot of them, it sort of is able to help you with how to fix it immediately. Now, what I'm going to claim is that a lot of projects aren't getting the best out of ESLint. I think the lint is actually underused on a lot of projects. There are a couple of reasons for this. One is there's a misconception that people tend to think of ESLint as more of a formatter, that it's all about white space, it's all about indentation, how the code looks. That's sometimes true for linters in other languages, but for ESLint, that's very much not the case. They do have some rules like this, but they're actually deprecating them, and their recommendation is that you actually use a specialized tool like Prettier for your code formatting, and you use ESLint for the less superficial stuff. And another reason is that the typical setup, you extend the recommended config. You extend ESLint recommended, TypeScript ESLint recommended, Angular ESLint recommended. When you generate a new project, that's the configuration you get. And then you haven't obviously enabled rules which are outside of this recommended rule set. And there are a lot of powerful rules in there. The fact that they're not recommended doesn't mean that they're not useful. There's a reason that rule is written. It's just that in some way they are not universal. There's maybe some difference of opinion between developers, but that's not saying much. Developers can sort of disagree about anything. Or it's just, it requires some configuration, like a naming convention ESLint rule, for example. It's not in recommended, not because people don't think you should have a naming convention. It's just that everyone has a slightly different one, so you have to configure it so it's not as simple as extends recommended. As far as your coding style being opinionated, that's actually a good thing. Your coding style should be opinionated. You should discuss it with your team. You should agree on some rules to make it consistent. This is definitely something that's worth investing your time into. And yeah, if there's some upfront configuration effort, so what? It pays off in the long run. You'll usually regret not adding lint rule earlier than spending some time researching lint rules. If you use write, linter can be seen as sort of an assistant for code reviews. It sort of gets rid of some of the burden of sometimes reviewers will give these sort of pedantic comments like this is formatted this way, this is my coding style preference. A linter can take care of those things. It's better if it's valuable to have an actual developer look through your code and talk about how the business logic is implemented, if it meets the acceptance criteria, and leave the sort of automatable stuff to a linter. To prove my point about going beyond the recommended configs, I'm going to list a bunch of rules which are really valuable, and I've grouped them into different categories. So one is related to code complexity, extremely common maintenance burden. You very often have these overlarge components which do 20 different things. Everyone's scared of touching it, but because it does so many things, you always have to touch it. It's typically a big pain point. It's usually a sign that we have separation of concerns or single responsibility principles, and this code is usually violating it. To some extent, that's a judgment call. You have to understand the code, but there are some signs which you can actually lint for that this is happening. And they're all based on having some sort of reasonable limit that you would have. So one of these is a line count, like just an overly large file or overly long function. Probably a good idea to split that up. Too much nesting, avoiding callback hell. We have that term for a reason. If it's importing a lot of stuff, then it probably has too many dependencies. That's also a good sign. And we have also a bunch of different complexity metrics, both for our TypeScript and also for our Angular templates, which definitely shouldn't have really complicated expressions, which is in some way measuring how much branching logic there is, what the cognitive overhead is for someone to understand this piece of code. So none of those are in the recommended, but I think they're really valuable. Another category is related to type safety. Usually this is regarding the any type, which is a sort of typical escape hatch. It's built into the language and tends to get overused. It's introduced this sort of safety hole where one thing is any, other things are derived from it. That then becomes any, and suddenly half the code base is untyped. One thing you should do is obviously enable strict TypeScript compiler flags. Fortunately, in the newer versions, that is actually enabled by default. So no implicit any's, for example. But that only gets you some part of the way. You can also fill in some things which TypeScript doesn't yet take care of with some ESLint rules from the TypeScript plugin. One caveat here is for some of these rules you have to enable linting with type information. Makes the linter a little bit slower, but it's able to be more accurate and catch more potential bugs. So those rules will have this little cloud icon. Oh, it's a bubble, this little bubble. So there's a no explicit any rule. This one actually is in the recommended config. I mentioned it just because it's relevant, but this one is recommended usually. No null assertions isn't. And then we have a bunch of different rules which are all about assigning any something, calling something that is of type any. The idea is you should give it a type as soon as possible and escape out of the sort of untyped world. And there's also a specific rule for Angular templates, which is this $any typecasting, which means the same thing. Speaking of Angular, we also have a lot of rules which are useful specifically for the Angular framework and also for RxJS, which is obviously built in. So it sort of looks at for a lot of the common mistakes that people make when implementing things in Angular. And it's also able to future-proof our code by telling us to use the modern feature, which is going to make updates to new Angular versions a lot easier. So first of all, there's actually just a general purpose deprecation rule. You should not use deprecated APIs, obviously. That makes updates a lot harder to do. There's a plugin for RxJS, so a bunch of useful rules in there. For example, no nested subscribe is a really common anti-pattern. You'll do a subscribe, another subscribe in there, maybe even another one. That's the callback hell pattern. You're using RxJS so that you don't have to do that sort of thing. So yeah, and a couple of other rules like that. Again, for Angular, not going to talk about all of them. Using on-push change detection, for example, it's really important for performance. And using some of the newer features like standalone components, control flow, optimizing your images with ng-source. And also, RX Angular also has an ESLint plugin, which has got this useful rule for not using detect changes in your code, which is sort of telling Angular, re-render yourself, because otherwise I wouldn't see the value. It's usually a good sign that something has gone wrong and it needs to be architected in a better way.
Also, don't remember to mention the unsafe pay counter, because turn it on and you will find out what memory leaks you have. Let's move to discussion now.
But yes, that's true. This category is maybe the most opinionated. Not everyone sort of buys into functional programming principles. But the idea is to avoid mutations, because when something goes wrong, you have some mutations, you have some side effects, it makes it really hard to debug the code and understand the code, because you don't really have any guarantees. It can sort of change at any time, and it's really difficult to follow and know where to look for the cause of the bug. This is one of the many principles of functional programming, also declarative programming, which we're using a high-level language. I would claim that we should be writing our code declaratively. And so if you agree with that, there is actually a plugin specifically related to these functional programming patterns and some useful rules in there. So one is immutable data. This is a pretty strict one. Just it's going to complain whenever you mutate your objects, you mutate your arrays. It always wants you to assign it to a new variable and use an object spread or an array spread, for example. Not using let, using const, because you shouldn't be reassigning things. Not using loops, because you should be using array map, array filter, these sort of higher order, more declarative constructs. And the final one is similar to the no let, just not reassigning your parameters, because that is a little bit unexpected. And final category is sort of building on top of the first talk we had, which is enforcing architectural constraints. This is maybe the thing people don't necessarily look at the linter as a solution for this, but it can do some interesting things. Code architecture, as previously discussed, super important. Once you get something wrong, it's super expensive to refactor it later. So it's really useful to have some guardrails so that things don't go wrong. Yeah, it's already been mentioned a few times. If you're using NX, definitely use the enforce module boundaries rule. It prevents some common mistakes like cyclic dependencies between your projects, or importing application code into your library code, because that's just the other way around from how it should work. And you can also get more creative with the configuration. There are some really good examples in the documentation how you can tag your different projects and then make sure you're not mixing scopes or different types of libraries in some way that's illogical. You want to have a clean dependency graph. Saves you a lot of pain in the future. And then there's also a sort of more granular rule, which is about restricting certain types of imports for certain types of files. Again, we've already discussed this dumb versus smart component pattern. Basic idea for dumb components is purely presentation layer. It shouldn't be. It should just be taking care of layout and styles and have inputs and outputs. It shouldn't be. It should be sort of this dumb, reusable component that is completely unaware of its context you're using it in. And then your smart component is where you do the orchestration, you do the data fetching, global state management, or you're injecting services there and passing the data down to your dumb components. And so in this configuration, I'm not actually aware of a strong naming convention for dumb and smart components. So here I'm just assuming, let's say, well, dumb components live in a folder that's called dumb components, and while smart components live in a folder that's named like that as well. And then we can use our linter to enforce some constraints based on how dumb components, what responsibilities they should have. So we constrict which imports dumb components are allowed to use. For example, we could say they shouldn't be importing the Angular HTTP client because they shouldn't be doing data fetching. That should be done elsewhere. They shouldn't be injecting the router because, again, that's from our global scope. They shouldn't be injecting other services. It should just be inputs and outputs. We shouldn't be injecting our NGRX store or whatever we're using for our global state management. Yeah, not importing any other services or other smart components as well. And with this configuration, we can actually automate those constraints to make sure we don't make a mistake. Now, I went through a lot of rules, and with the one exception, none of these are in the recommended config, so there's a good chance you don't have those enabled for your projects unless you spend some time configuring the linter. Now, what to do if you want to enable some of these stricter rules? If it's a big code base, there's a good chance it's not so easy as just enabling them, and now it passes, and now it's all fine. It's quite common that maybe there are actually some violations of these rules, and you'll get a lot of errors or warnings reported, and they're either too many to fix all at once or just too complicated. They're sort of a sign of some deeper problem, and you just can't practically stop and fix it all in one go and then move on. A lot of the lint rules I talked about here aren't the auto-fixable kind where you can just do it automatically. Like if your line count is too big, ESLint doesn't know how to split that up for you. You have to make that decision. There are some workarounds that people do when they want to enable a new rule and not have a failing lint job in your CI. One thing you can do is just, if the rule is failing, you set it to a warning. So your lint doesn't fail, but you still see the warnings in your IDE, in your CI logs. Unfortunately, if there are a lot of warnings, people just tend to ignore them at a certain point, and you don't really have a good overview of if it's getting worse or if it's improving. Another workaround is simply to disable the rules that are failing and put a comment in there and say, we'll fix it later. And so it's temporarily. It's always well-intentioned, but of course, in practice, that comment will be several months old. Once it's disabled, it's a solved problem. And of course, once you disable it, you have no visibility. You have no idea if since then it's actually, maybe you could even enable it now because you fixed it, or it's actually gotten even worse and you have no idea. So what we're really looking for is some way to track if those error counts actually going up and down. And so it's just a basic ESLint setup doesn't quite get us there. We're going to talk about the solution later on. But first, I'm going to talk about some of the other tools. I mentioned third-party packages. Obviously, you want to keep those up to date, do those updates frequently, makes things a lot easier. That one's pretty obvious as far as technical data is concerned. This slide is about vulnerabilities, which can be reported by your package manager. It's actually a simple command that you can run. It just lists all of the vulnerabilities you have in your code base based on the packages that you have installed. So npm audit, for example, or some equivalent for yarn or pnpm. In practice, I strongly recommend, if you're running this command, to filter out development dependencies, because they typically don't matter. They're just that's your build tool, your testing tool. It's not code that the user runs. It's not something where the user can, which the user can exploit with some malicious input. It's way less of a priority than something in your actual production dependencies, which are actually being run in your application bundle. You should run this command regularly so that you know about these vulnerabilities. The problem is, typically, the way we do is we put it in our CI and we don't merge pull requests if there's failure. And this flow doesn't really fit well into that. The problem is, when a new vulnerability is reported, then it isn't immediately fixable. It takes some time for the package maintainers to publish a security patch. And if it's some indirect dependency, then the package in between also have to do an update, and it could be a few weeks where you're just waiting for someone else to fix it, and it's outside of your control. That's another of the problems. It just sort of happens randomly at some point. When you last ran the pipeline, the vulnerability was there already. It's just now it's been reported, and this is when you ran it. And it's generally unrelated to the code changes you have in your pull request. Like, that's not what triggered the warning. It's just that's how it looks, because that's where the CI failed. But it doesn't make sense to actually block those code changes. Again, there are some workarounds that I see people use. One is you can set minimum severity levels, so you can ignore like medium and low severity vulnerabilities. That's sort of a rough tool. You tend to miss future vulnerabilities, which may be important. A slightly better option is that you, again, temporarily disable them. the vulnerabilities have like IDs. You can put those in a config file, and you can ignore the specific one, which we can't fix, but you'll still know about different vulnerabilities. Those will still be reported. So that's slightly better, but again, it has the problem that we typically don't return and then make sure that we actually fixed it and removed the ignored vulnerability. You may know some services which specialize in auditing your dependencies, like in GitHub we have Dependabot, for example. That's has a sort of much more reasonable flow. For example, automatically create pull requests where it's updating your dependencies and it sends you the vulnerability reports regardless of what your pull requests are doing. It doesn't quite work for Angular, unfortunately, because in Angular, when we do updates, we actually have these migrations, these schematics, which are not just bumping the versions, but they're also applying some code changes, which the Angular team, or the NX team, if you're using NX, has automated for you. And that's really useful to have. So Dependabot isn't quite the right tool in this case. Moving on to testing. Testing's super important, obviously, for stable software. It's consistently shown in studies that test-driven development actually makes you write better code, because when you're designing your code and you're thinking about how you're going to test it, you tend to come to the conclusion that it needs to be isolated, as few dependencies as possible, because otherwise you have to do a lot of mocking, and it tends to lead you to have less coupling in your code and make it more modular in general. So outside of just having it tested, the architecture tends to be a lot cleaner. Unfortunately, in practice, this is again another thing that projects quite often start off in the interest of going fast. Let's not do the test, it slows things down. Particularly true of front-end projects, because there it's actually a lot more intuitive to just ng-serve and click through it the way a user would. Automating that in an end-to-end test or something isn't that straightforward. So it just sort of feels easier, but the manual testing at some point just doesn't scale. There are some metrics. The one I have highlighted here is called code coverage. Sometimes it's confused for test coverage. It's that sort of more general sort of conceptual thing, like what testing scenarios we have, if it's meeting business requirements. It's not generally measurable, but code coverage is measurable. And what it does is when we run our tests, it instruments our code, and it'll tell us how many times a specific line of code was executed, if a function was called, if we executed some if or else branch, and we get the percentage overall for our project. And if we want to have some verifications, then we can also set thresholds in our configuration. So for example, we'll say the test will fail if the code coverage goes below 60% of branches covered or something like that. The extreme case is people go for 100%, which I don't necessarily recommend. Again, it's more practical, particularly when you're introducing tests later, you're just testing the new stuff. But if you're setting these thresholds, then you sort of have to think about, well, the old stuff isn't covered. The better metric here is something that's called patch coverage, which is basically the same percentage, but just for the code changes that you introduced, regardless what's in the other code. And that's, again, a lot more practical approach. Moving on, we have Lighthouse, which, again, I'm sure you know. Web performance, web accessibility, maintained by Google. Usually use it with the Chrome extension, and you can do a one-time audit of your website. There's also a CI integration that they have built in. It's called Lighthouse CI, obviously. And this is actually going to collect your Lighthouse results, and it can also do assertions based on some audits if they are passing or not. Now, the thing is, if you've just integrated Lighthouse and you haven't done a lot of work on optimizing your Lighthouse scores, it's quite likely that their recommended audits will fail. Actually, Lighthouse teams expect this to happen, and it doesn't suggest that you add assertions if you're getting started out. You should only collect the results so that you know about it, but you should add assertions when you're ready, or just disable the assertions which are failing, which again has this similar problem of losing the visibility. They also have a self-hosted server which you can run, which is actually going to store your results for every commit. If you have to set this all up, but it will give you like the data retention and the sort of the historical data, so you can actually compare reports between different commits, and it'll actually track your progress if you're getting closer to, or if you're improving your lighthouse scores. This is actually a really good way of doing this, and was an inspiration for our tool. Final tool is rated to bundle size. This I put in here because Angular has a very specific sort of way of handling this. So as mentioned before, key factor in load time performance, just it's how much code our browser has to download and how much it has to pass in order to render something to the user. So we want to ship as little code as possible, only what's needed, etc., etc. Angular actually has something built in, and it lives in your Angular JSON, or it's project JSON if you're in NX. And it's something they call bundle budgets. So actually, and by default, they include these. So you'll have some limits which are configured for your main bundle, for example. There's a limit at which it'll print a warning, or a limit at which it'll actually error. And an error means your Angular build will fail. You won't actually get your build output because a budget check failed. This is, I would say, well-intentioned. You should care about your budget size, but in practice, it has some problems. First of all, it's an arbitrary limit. And when it actually fails in your CI, there's a good chance it hasn't identified what the source of the problem is. The thing is that when you're developing, it's actually quite normal that your bundle size goes up a little bit. You are adding new code after all, so some change is expected. What you really want to look out for is the big changes. Someone imported a huge untree shakeable library in your main application path, and suddenly we've doubled the bundle size. That's what you want to look out for. Unfortunately, if you just have a threshold, that you might not get notified about this at the right time. It could be that your limit is up here. If you have a generous limit, someone made a big mistake, your bundle budget doubled, but it was still below the threshold. We make some changes in the meantime. They're all small. They're not really relevant, but whatever the latest change that goes over threshold is going to trigger a build failure in our pull request, and we have to now solve this in a pull request that isn't really related. Typically, what you see in these projects is they just increase the limit a little bit, wait for the build to run again and pass. In the meantime, someone merges a pull request, they do it again, they get another bundle budget error, and they bump it again, and it is far from sane. Now, this is where I introduce the tool we've built. We is flow-up and push-based. And as I already mentioned, the idea is to integrate all of these different tools, which are all useful in their own right, but they only give us part of the picture, into one comprehensive report where we can see sort of the combination and the more sort of comprehensive view of what the project state is. And then we focus on your changes and if you're actually making improvements or not. We'll compare reports whenever you make a pull request, for example, and tell you it's improved, it's gotten worse. You just get a comment. It's not blocking your CI, it's not getting in your way, but it does give you the visibility and something you can keep track of. The core of this product is fully open source. So there's a CLI, which sort of runs everything. And also we have this concept of plugins, and we distribute some plugins ourselves, which you can use to get started. And that's basically what's running the individual tools, which are then combined into your report. One of our main design principles here was to be extremely flexible. Different projects have different needs. We'll give you some our own opinions on how you should configure things so you can get started. But if you need to adjust it based on the specifics that you have, then you can do that. There's actually a config file, and in general, everything can be configured. And I mentioned there are plugins. You can also build your own custom plugins. They're not any different than the plugins that we maintain. They're first-class citizens. If you have some other tool that you think is useful and you would like to integrate, if you have some very specific problem for your project that you really need to measure, then you could, if you want to implement a plugin for that, then you can, and it'll be integrated along with everything else. We also have some enterprise features which are built on top of that. This is what we call the portal. Basically, it's an application which gives you a sort of user-friendly interface to see your reports and get some rich data visualizations, etc. And then the main feature you have here is data retention. That we actually store your reports in a database whenever you make a commit, and then we can show you progress charts, which give you the overview of how you're improving or if you're regressing, highlight some recent trends, and sort of use this historical information about the state of your code base. I'm going to talk about some of the key terminology that we use. I already mentioned plugins. That's what usually is wrapping some other tool, and it's integrating it into a code shop. That's what actually runs what's called actually audits. That's the other terminology. The audit is just some sort of check that we have. The data format is inspired by Lighthouse. So if you know what the Lighthouse audits are, then it's the same idea here, basically. We have a score, which is just a value from 0 to 100. 100 is the perfect score, so that gives you like the information of how good or bad it is. And in addition to that, we also have some numerical value, like the number of milliseconds something took, a file size, an error count, something like that. That's also interesting to measure by itself. And there's also other additional details that an audit can include in its output. For example, it can also list issues directly in the source code for us. Now, to give you some idea, here are some examples which are actually from our official plugins, so you can understand what an audit might represent. So the first two here are ESLint rules. We directly convert ESLint rules to code push-up audits. And the scores here are basically a binary pass or fail, so 100 or 0, based on if there are errors or not. And the value is the error count of the number of warnings, so that you can also track if that is going up and down, even if it's already failing. Another example here is a coverage metric, in this case, function coverage, which is just the percentage, basically. That's what the coverage score is. So the percentage is a score, and it's also the value in this case. We also have a plugin for your dependencies. So for example, we check your vulnerabilities. In this case, the score is sort of percentage of how many of your packages are vulnerable, and the number of vulnerabilities is the value. Similar for outdated packages, we also show you how many of your packages are outdated and how many packages have an outdated version. And the final example is a Lighthouse audit here, largest contentful paint. That's one-to-one, basically. The score means the same as it does in Lighthouse, and in this case, the value is a number of milliseconds that it took to render. Now, going back to the beginning where I talked about we have this communication problem with our managers, that the audits are maybe more valuable for us as developers, but a manager typically needs something a bit more summarized. And for this reason, we have this concept of categories, which are supposed to give you a high-level overview of what the state is, reduce it to just a few clearly understandable numbers. So categories, they have a score. Again, it's similar to Lighthouse. Categories are actually configured to use different audits, and it basically takes an average of those audits, but you can also assign different weights if some audit is more important than another. And you basically have this formula that lives in the config file, and that you can configure how your category score should be calculated. One thing to notice here is that our categories can actually combine audits from different plugins. This is something that's really hard to get if you're using a bunch of different tools. They typically don't integrate, but in our case, we can do it. We can have a performance category, and it's going to use a bunch of Lighthouse performance audits, but it could also have a few audits from a bundle size plugin, or you could also have some audits from ESLint, which are somehow performance related. We can combine it and list it all in one place because it's all related. One minor thing, you can also include audits without them having an impact on the score. You just give them weight 0 and they'll be listed, but they won't actually influence the score as well. So it's just like some additional information that's relevant. Some examples of categories you might configure, so performance or security, or yeah, basically the lighthouse categories you could forward here. Or here, for example, it's an example of a category which for some project it would be really important, for another it would just not be applicable, like localization. Some projects have translation, some projects don't. These categories, you can add categories, you can remove categories, you can set whatever categories you want. How does the integration work? So, as I mentioned, CLI and also some of our official plugins are open source and they're published on NPM, so you just install those in the usual way. Install CLI, install some plugins, which we maintain to get started quickly. And then the main thing is to configure a code push-up config file. And this is where you import your plugins and configure them, and you can also define your categories, which you want to be included in your report, among other things. Then you run the code push-up CLI and you get a report. If you're just running it locally, you'll get actually a markdown file, which just sort of renders the summary. But in the end, you want to automate it, so you want to add it to your CI pipelines. If you're using GitHub, then it's really easy. We have a code push-up GitHub action that you can just include, and it takes care of everything. And then once you've configured this, every time you make a pull request or merge request if you're on GitLab, then you'll see these comparison comments which are telling you what impact your changes had. And this looks something like this. So there's a comment here which will appear automatically on your pull requests. And in this case, it tells us that our report has actually improved because we've made some improvements to the coverage category, and it shows us those scores and how much they went up by, and it also lists the other categories that we have configured. And if we want to know more information, we can also expand the individual audits that have changed, and we can see these individual coverage metrics and how those percentages changed. I'm going to show that also in a demo, but first I want to talk about plugins. I already mentioned we have some official plugins, so just want to go through those. First is a plugin for ESLint, which is going to basically take whatever ESLint config you provide us, converts all of those rules to audits, and includes those in your report. We also have a code coverage plugin for basically any testing tool, because we just care about the coverage format. So you'll get those percentages included in your report. We have a JS packages plugin, which supports npm, yarn, pnpm, lists vulnerabilities and checks for outdated versions. And finally, we also have a Lighthouse plugin, which basically integrates Lighthouse and integrates those audits that they have. And these are just the ones you can use today. We're also working on a bunch of others, like a TypeScript plugin, a bundle size plugin. There are a lot of things that are on our roadmap. But I also mentioned you can create custom plugins if you have something that's you want to implement yourself. So I came up with a sort of fairly simple example of how a plugin might look like, just so you can sort of understand the basic anatomy. Here, what you see is actually a code push-up config file, and I'm actually defining the plugin inline. More typically, you'd be importing it, but I wanted it to be on one slide. And here, my plugin consists of a plugin config object. And what this configures is basically some metadata for my plugin. We have a slug, which is sort of the identifier so that you can refer to it. Also a display title, you can have an icon. And we also list metadata for all the audits, which will be included by this plugin. In this case, my example is that, let's say we're migrating a code base from JavaScript to TypeScript, and we want to have some measurements of how close we are to completing that conversion. So I have a single audit here, which is just going to be look at the ratio of .ts and .js files, and going to give me that percentage. And the actual measurement is done in what's called a runner. So this is where your actual logic belongs. And its job is for all of those audits which you've registered up here to give us the outputs. In this case, by the way, this crawl file system function here, you see is being imported from a package called code pushup utils. This is also something that we provide. The utils are used by the CLI itself, but we also provide them as a standalone package because We have some useful helpers in there for creating custom plugins. So there's a lot of things that you can already use. In this case, I'm using the crawl file system utility, which is just going to search through my code base, look for all .js and .ts files, and then I can just filter based on the file extension, and I'll create a percentage of how many TypeScript files there are as the score. The value will be just the number of JavaScript files that haven't been converted yet. I also have a display format where, again, I'm using a helper function to format it, and so it'll say 2.js files or 50.js files. And this is optional, but some audits you can also add some additional details. So here it makes sense to also list the files which haven't been converted yet. So that's we can use the issues data type for this. We also have tables, and we'll be adding some other data types in the future. And so here, for each of our files, we're going to have a message, a severity level, and we can also point it to a specific source file. Now, time for a demo. So should I zoom this in a little bit more, or is it readable? Is that okay? I'm going to say yes. Okay, so here I have a GitHub repo, and it's already integrated code pushup. And so we have a code pushup config file configured here. And here it's just a TypeScript file. We're importing some of the official plugins, and we're integrating them in our configuration. So we have a plugins where we import our ESLint plugin, our JS packages plugin, coverage plugin, give it some parameters so we can customize them. And then the other main thing is we configure our categories. So we have some metadata for the category, and then we reference audits from the individual plugins here. And that's how our categories get created. And then for our GitHub Actions, we have a workflow which is going to run the code pushup CLI. We're triggering it on push and pull request events. And the setup here, this is sort of boring generic stuff. It's just check out the repo, install node, install dependencies, and then the code pushup logic all happens in this code pushup GitHub action, which we are using here. And this is going to collect the report whenever we push a new commit. And if it's a pull request, it's also going to compare it to the commit from where we're merging into, and it's going to create a comment on our pull requests. So if I want to see that in action, I'm going to go to a pull request. And here we have a code pushup comment, similar to what I had in my slides. Yeah, it's compared the latest commit on my pull request branch with the main branch, which I'm merging into, and telling me basically what the impact is. Lists my categories, which I've changed. In this case, I have a bug prevention category, which has improved, and the coverage category has improved a bit as well. So in this case, it's good news. If I want to know more about why those categories changed, then I can expand the audits down here. And I see that the bug prevention category is improved because some ESLint errors have been fixed. So previously we had a few errors, but now we've fixed them and it's passing, so our score is improved. By the way, if I click on these, then I get links to the documentation because we can auto-generate that. So if you don't know what the ESLint rule is measuring, then you can find out why here and why you should care about it. And yeah, the other audits are from our coverage plugin, which is just giving us those percentages, and they went up a little bit. So we know about that as well. And then our final one is actually a slight regression. It's a different ESLint rule. And it was already failing. We had 6 warnings previously, but it actually went up to 16 warnings. So we made things a little bit worse. And here we find out about this. And if we want to know what new problems were introduced, then we review the pull request. We look at our changed files. And when we're scrolling through here, you can see we have these what's called GitHub annotations, these sort of comments that you see at the actual line of code, which is the source of the problem, and you see the actual message directly where it applies. So quite good for getting some actionable feedback when you make something worse. So this is all of this is the free open source version to demonstrate the additional features you get if you have the code pushup portal. then in this case, because I have the portal integrated, I also get a link included in my comment. So I can open this comparison in the portal, in this user interface we have. Hopefully that's big enough. And here we see the same data, but because it's not just a markdown document, we can make it more interactive and a bit easier to explore. But it's the same data. We see the categories, how they changed, and we also see the audits that changed, as well as some unchanged audits. We can also, so all the same information is here. We have the ESLint audits, we have the coverage audits. We see how the values changed, how the scores changed. We also see which category they're included in. And crucially, we can here directly look at the details. So if I'm interested in this audit, I can expand the details, and here directly I see the actual issues that were resolved, in this case, the lint rules that were fixed. And if I expand these, I can actually see the snippet of code with the highlighted line directly in the portal. Or if you want to see the whole file, then you can click here and you see the same file in GitHub again, navigates you to the line of code. And also we have a documentation link again, so that you can understand what is being measured. And you can also interact with this view and filter it, particularly when there's a lot of data. That's very useful. So we have these status counts, for example, so you can just, if you only care about improved audits, then you can filter them out like this. You can also, if you click the categories, you can filter by specific categories, or you can click them up here, and that also works as a filter. And some alternative views. So for example, if you want to start from the category and dig in from there, then you can actually navigate through the full hierarchy. So you can expand the coverage category, for example, expand the coverage audit. You'll see, again, all of the details of the issues. In this case, it's some branch that hasn't been covered. And again, we can get all the way through to the line of code. So apart from having this sort of improved user interface, you also get the data retention. And we can see that if we go back to our dashboard, here, for the project I've selected, you can have multiple projects or multiple repositories included. It automatically shows my latest report for that we maintain and how to configure those. So if you're interested, please check it out and let us know your feedback. I do have a quick summary. Just to summarize what we talked about. So we talked about technical debt, how it's a common cause of burnout, typical pain point. If you have some experience in the industry, you feel it in your bones, you know what the pain is. And then we talked about the communication problem when we try to translate technical things to people in non-technical roles, how it's really good to be able to quantify it so that they can actually buy into it and have some understanding of what we're talking about. We went through a bunch of different tools which are useful, or at least the ones that we could think of, which measure quality, but just from some specific aspect. And then also we talked about how the basic integration you get is difficult when you need sort of a long-term incremental approach, when you can't just fix it immediately. You have to take your time with it. And so that's basically what Code Push-Up is trying to solve, to give you a sort of comprehensive solution where it includes all the different aspects that go into code quality while keeping you in the driver's seat. You can configure everything exactly the way you want. You don't sort of have to use our presets. You can use your own. You configure it based on what you're interested in measuring. And that is the end. Thank you for listening.
How many questions do you have? 1, 2, 3, and then we go on. Here is your Mac.
Thank you.
Give you another paper here. 820, if you're curious what your number is. Here you go.
Thank you. You've shown the integration with GitHub, but what about other products like GitLab, Bitbucket, or something like that?
Yeah, so we have support for GitLab as well. We don't quite have the GitHub Action simple CI integration, but that's definitely on our roadmap. So yeah, we have customers on GitLab, so that's also something that we definitely want to have first-class support for.
Mm-hmm. Okay, thank you.
Can we go to your colleague?
Yeah, thank you. So you talked about immutability linting rules, and I support them somehow, but sometimes immutability can cause performance issues. I mean, you know, because we worked on the same problem and on the same project where we identified one of those issues. How do you plan to opt out of ESLint rules? Just with the comment?
Yes, basically. The ESLint disable comment is there for a reason. In general, the rule should be something that's usually, it should be the case, but there are some exceptions, but you should have some comment there, ideally with some explanation of why, hey, usually I'd write this immutably, but this is some hot code that I actually need to optimize. It's good to have the rule there and give some sort of context there. So
you also suggest to disable by line and not by file?
You could also do it by file, if that makes sense. That's also configurable. But.
Okay.
I would say keep the API immutable, immutable and keep the inside.
Yeah, that's a good principle. So if you have a function, its implementation could have mutations, but it's still good if from the outside it's a pure function. Yeah. So it's like uses a map and it modifies something, but in the end, same inputs give you same outputs. So if you have some mutations, it's good to sort of isolate them, separate them, but it doesn't sort of bleed into your architecture.
You speak a lot about managing the technical, about augmenting to the management the technical depth. And in the normal project way, you have to add some rules, ESLint rules to your project. And then the score is going the trend is going down because you add rules. How you augment this case? Because the management has now a fixed score with 92, for example, and afterwards it's going down massively, and then you have a problem to augment this, I think.
Yes, so well, you need to tell them about that, basically. Or you could get around it by just creating a category of a different ID if it's a big problem. But the more typical situation is when you've started integrating this tool, then that's when you actually do the strict config, because you can be as strict as you want. It doesn't matter that it fails, so you do the proper research, set it up. By the way, one thing I didn't mention, we actually have an ESLint config. So if you just extend code push-up ESLint, we have some presets for Angular and other frameworks as well. So the rules I talked about are actually included in there. So if you want to have a strict lint config, then that's something you could look at. And yeah, usually you configure the strict rules, and that's when you start measuring it, because that's when it's interesting.
Thank you. Somebody screamed while they talk in the back. Is it a question now, or is it answered? Good. Answered. Then somewhere here, hand raises. Let's go from left to right.
In a GitLab pipeline, is this tool a replacement to the lint stage, also the ESLint stage, or would you still need a pipeline step for ESLint and then run this tool in?
Typically, you would keep that. The practical way to do it is you have an ESLint config for your CI, and then you have a strict ESLint config. So your CI ESLint config could extend the strict one and turn off the rules which you can't fix immediately. And you would give code push-up the strict ESLint config, so it knows about all the failing rules, but your CI is still passing.
Okay.
So that at least you have actually the checks that the rules which are working already aren't failing suddenly.
And speaking about GitLab, the GitLab integration is also documented on the website for tryout. Or what's the status of the GitLab integration? Because you said it's on the roadmap, or is it?
Yes. So you can already run the code push-up CLI in your GitLab CI/CD. That's quite easy to set up. For the comparison comment, it requires a bit of extra work, and we'd actually like to provide some templates to just make it easy to configure it for you.
Okay.
Maybe a short question. Is it not secret? Can you name competitors or similar solutions from other companies?
So I think the one that's mentioned most often is SonarQube, which is what a lot of companies use. It's sort of part of the furniture. And that focuses just on static analysis. Also, I think they have some code coverage, maybe vulnerabilities, but you won't integrate stuff like Lighthouse audits, for example. That's not what it's built for. And then another difference we have is configurability. Like, we make this very easy for you to configure and adjust based on what you want to measure. With SonarQube, typically, you just use their presets and their own opinions and follow that. I think it's possible in the self-hosted version to create some of your own plugins, but I don't think people do that very often. It's
only possible in the paid version.
Yeah, in the paid version, and I think they're implemented in Java or something. I don't see people customizing it very often.
Just because I'm a big fan of the tool. I also believe it's really cool that we stay in the Java, in the TypeScript ecosystem. So everything we write is in the same code that you use to write your own apps, and it makes it incredibly easy to extend it, to use to understand it. We have zero learning curve. And also another tool that we collected basically for free is the open source version, the code coverage. Code coverage. You don't have to pay for code coverage, because we give you the code coverage.
Yeah. Or yeah, Dependabot is another example. Basically, these services exist, but they're focused on just one thing, and if you want to combine it, it's very difficult to do that. So that's one of the main.
Or you have Cypress dashboards that you need to pay for, and you can create a report for us, and we just show you the same information.
Yeah, we actually have a customer which has a big, as I mentioned, sort of flakiness end-to-end problem. They want to have some overview about it, and so in this case, we built them a custom plugin which is measuring their Cypress tests and showing them which ones are slow, which ones are failing, etc. So it's also valuable for their QA team.
Three more questions, if you're quick.
Okay. I just have a quick question about, do you know a plugin, which is whenever there is a maximum bundle size or a maximum additional bundle size, so somebody exceeds that, that so usually developers have to create a bundle and then upload it to the Webpack bundle analyzer and so on, and all this manual labor. Do you know a good plugin which actually does it automatically and it just shows there as with everything?
Bundle size, right?
Okay.
You said bundle size.
Yeah.
Yeah. Okay. Yeah. So we want to build like a proper plugin for that. We have actually an example plugin which is sort of does basic file size assertions. As far as good bundle size tools, then I would refer you to Vojtech because that's his favorite topic. He loves talking about these tools. Yeah, size limit is one I know.
Do you also integrate with Bitbucket?
We don't currently support Bitbucket, but we probably will at some point.
We need it.
First two, okay.
Again, a question on integration. Do you have any guidelines for on-premise CI/CD integration, like Azure services which are on-premise, which is not?
I'm not sure I've heard.
Like TFS, like Team Found, we have our own GitHub self-hosted in the company.
Yeah.
Can we integrate your plugins with it?
Yes.
Do you have any guidelines somewhere in documentation?
Yeah, it doesn't really matter if your GitHub or GitLab is self-hosted. It's very little difference. When you self-host a portal, there's an extra config option, that's all.
Okay, and do you have, in config, can I say that the reports are saved in a separate repository so that later on I can compare it? Or I don't have the enterprise license, but I can actually go back in history and say that, okay, these were the report or these two versions are compared. How does it look?
Yeah, so in the open source version where I didn't show, when you have the GitHub action, you also have some artifacts, which gives you the sort of raw report data every time. So there's a JavaScript file and there's also a Markdown file, which is sort of more readable. So that's something that you also have access to based on what your artifact retention policy is.
Okay, thank you.
Thanks. Hi, thanks for a great presentation. I'm one of those awful middle managers at the start of the talk who.
Sorry for making fun of you.
No, it's okay. I deserve it. But you know, and forgive me if you mention this. Honestly, memory's like a sieve. But the one killer thing for me as a terrible middle manager to really believe some of this. And you've got the access, because you've got the access to GitLab or GitLab or GitHub, is to tie it to something like DORA metrics and sort of, for example, there are a million ways to cut this, right? I know that I'm a little bit scared of saying this out loud, but really it comes down to developer velocity, right? Because fixing all that tech debt, ultimately, what does it mean for the companies? It means that actually our throughput stays, let's say, stays constant, as opposed to we let the tech debt, mount up and the company slows down to a crawl to the point where it can't do any development. And I just wondered if you had that integration or you thought about it, or maybe you just think it's an awful idea. I don't know.
We have thought about it. We actually have a customer which uses code push-up, but it also has its own other sort of data analytics. So in their case, they export it to BigQuery and integrate with other tools they have. And so they definitely use it for DORA metrics that they evaluate. We don't have a specialized plugin for it, but it's definitely something that we're considering. But it's a bit complicated because it very much depends on, everyone has a slightly different setup and how to measure it.
It's hard. Anyway, thank you. Thank you very much.
I wanted to ask, how long does it take to generate these reports? So, like, for example, we have a GitLab pipeline, which already takes like 20 minutes. Would adding this tool add another 2 minutes to creating each pull request, or is the performance quite like under a minute to generate the report? Do you have some
it very much depends on the plugins which you've integrated. In general, if it's a really large code base and you have ideally some sort of monorepo tooling, then we actually recommend you split it into different code push-up projects, because then those can individually be run in parallel and they're quite fast. And yeah, we're very much working on monorepo support, for example, for NX. We want to have a really easy integration.
Okay, thank you.
Last one. Here we have the number already.
So,
If you want to know it.
thanks. So, great talk. Thanks for that first. And you mentioned this like with managers, what they like. You learn us how to do the things, but like in between, do you have any suggestions like for the managers from developer how to go to that path? Because that seems to be problematic, at least in my experience.
Suggestion for the managers. Well, typically,
Whoever is concerned.
It's it's more typical that developers want to fix the tech debt, and it's more like they want their managers to know about it. But sometimes it's the other way around, that the managers are concerned that the developers have some really awful code in there, and then it's the other way around, that they want to measure it and they actually want to plan tasks based on, hey, this is a really awful score. Can we improve it in the next sprint?
Okay, that also means that we have to do it first, but I meant like in the preparation. So we know we have a problem, but we don't have time for it. How can we approach to our managers in this situation? That I meant. Funny suggestion. Funny is bonus.
Yeah. Well, the don't have time for a problem is basically why Code Pushup is set up this way, that it's not something you have to fix all at once. You can just do it gradually and just know about it.
If you remember the Angular bundle size CLI stuff, like if you have a problem, you don't know why, it stops your build, it does not put out anything. That's like the exact opposite what we try to unlock with the tool.
Matěj also mentioned with the Scout tool, like leave the component in better, say that example. That's not virtual, it's linking with all improvements.
Yeah.
And then we happy that you are improving the more and show the colleagues that don't.
Yeah, you can show off that you have a positive comment on your pull request and point out colleagues which have bad comments.
Also, it replaces most of the code.
Last round of applause. We have to shorten the break also due to overtime, so now it's not. Julian, last talk. 50 minutes break is over. I hope you enjoyed it. It was your last break for today. From now on, no more breaks in your life. Get used to it. Let's talk about performance, one of our favorite topics with one of our headliners of this evening, Julian Jandl, on peak performance with partytown, call-on tracking, the third-party challenges in big enterprises, a case study, longest title ever, mentioned on a meetup. Applause.
Thank you, Michael, for the very lovely introduction, as always. Now I messed up my own setup, so this one should be it. Just a sanity check. Yeah, okay. Lots of workspaces. We have a lot of stuff to talk about today, or this evening. We already talked about a lot of stuff, but this will be even more stuff. But I hope it will be very entertaining. I try a different style this evening for the very first time. I try a different style, and I hope you enjoy it. I consider myself to be a good storyteller, and that's what I'm going to try out this evening. And I have one question up front to just wake up everyone up. Do you know, or did you ever heard about partytown? Do you know what it is? Hands up. 1, 2. Okay, I know you, I know them. Okay, partytown is like, that's perfect, because partytown is very niche and very edgy. It's about third parties, and I wanted to have third parties and performance and partytown in one title. That's why it got so long. So, just why you complained. That's the reason behind it. Okay, so storytelling. I told you about storytelling. Once upon a time, there was a poor app. It was really, really poor. Its name won't yet to be revealed. I will do in the middle ending stuff, but it suffered severely from bad performance. Okay, it was ugly, really ugly. So it went to the doctor. Okay, you see, doctor? Yeah. The doctor did the diagnosis, and it is too much third party. Not only requests, but also scripts. A warning up front, because what you will see now or will witness now is not cool. The following images are graphic in nature and might be disturbing for some viewers. So please, if it's too much, just you can leave the room. I don't mind. Okay, it's hard already. Some flame charts. We want to see how the app behaved in its natural state. Okay. So you see, this is how your browser will interpret the scripts that are running on your client. On your front-end client. This is the JavaScript code executed. And you see, I've marked all those stages, and most of them say tracking or recapture or something that is considered to not be first party. It's not your code that is running here. The browser is executing stuff that, like, you didn't even write it, but it has to execute it. This is even worse. Like, this is just, I would call it the yellow wall of, I don't know, brutality. It's not only the yellow wall, it's also the other wall. It's also occupying your network threads. Like, this is how it looks like in your network thing. You have GA3, Facebook, DoubleClick, GA4, ad service, Snowplow, more GA3, then some Adobe things and whatever. You cannot imagine. This is how it also can look like. Tracking, tracking, tracking. Some, oh, lazy loading components. This is actually your code. This should be executed. Navigation tracking. See this? Half of this time is just spent on sending some information to some third party. Again, network thread. You see all those red boxes here? Collect, collect, GA audience, collect, 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 collect. Collect is always Google Analytics, by the way. Or this beautiful creature, 1.2 seconds, 1.2 seconds. It's like a second frozen screen because some third party was executed. It's awful. So let me quickly introduce myself. I will be your performance doctor for tonight. I'm Julian Jandl. I'm performance engineer by heart and soul. I'm trainer and consultant at the company Pushbase, and also open source maintainer, obviously speaker, otherwise I wouldn't stay here today, and sometimes I'm also trainer and consultant. So let's talk about third parties. There are a lot of third parties, and there are a lot of categories of third parties. You can have ads, analytics, whatever libraries that help you to have some utilities, or a CDN, and then there is the freaking end boss that is sitting here. It's called Tag Manager. Tag managers are the end boss of third parties because you have no idea what's coming from them. They are the puppeteers of third parties. We'll talk about that in detail later. Third parties. You can have Reddit, TikTok, Snapchat, Meta, Google Ads, like whatever brand you name, they have some analytics going on and you can install them and can use them. And if you go more enterprise, you will use them for whatever reason, but that's what we witnessed. And that's not what we witnessed. It's like what the Web Almanac, that's like a glossary where you can read up data from real web applications, came to the same conclusion again. 49% of all websites that you approach mobilely have at least one third party. So essentially, the whole web has it, okay? The more enterprise you go, and this is like a chart showing the more users you have, the more top ranked. On the left side, you see top 1,000 websites. On the very opposite side here, like all websites, just a median over across all of the websites that exist in the web. You see, like the bigger your website is, the more third parties you have in median. 45% of all requests from all websites going through the web are third-party requests. It's insane. Like half of the web is driven not by you, by someone. We don't even know. 34% of those 45% are scripts. And this is now getting like really horrible because this means 1/6 of the whole web is driven by scripts that we don't own. And they hit performance badly. They are competing with the priority you have on the main thread. So whenever they get executed and your app gets executed, they run on the same priority, on the same thread. So they mess up with your code that you have written in the first place. You cannot opt out because marketing and tracking teams will the fuck yell at you, really yell at you. You cannot opt out. And you cannot improve their performance. It's not your script. You just like put a head script tag in your DOM and that's about it. You have no control about it. It's getting executed, that's it. So yeah, there's also investigation, like official data, and it looks like YouTube is really hitting hard. So this is a chart showcasing third parties that block your main thread. Blocking tasks in this manner means they cause scripting tasks to be longer than 50 milliseconds. And you can see YouTube, Google Maps, other whatever Google APIs, Facebook, and then here you see, let me move there with the mouse because it's so important, the end boss, Google Tag Manager, which is probably the reason because all of the others are here. Let's talk about a task because I said like blocking, it's blocking your main thread. This is what it's looking like when your browser is executing work, your first party work. So you have a function in your app that's called work and you have a function in your app that's called other work. It has to execute it, maybe on a click listener. Then the browser also has to do some rendering and painting work because like you change styles or you added a new DOM node. So it has to create a new frame. That's where it does it. So let's sprinkle a little bit of tracking in there and ta-da, you have a long task. You see it here, 64 milliseconds. It's more than 50 milliseconds and everything that is longer than 50 milliseconds will be considered as a long task. Why is this bad? Because there's this INP metric, which is new since the 12th of March this year and replaced FID. It's a new core web vital. And if your scripting tasks exceed more than 200 milliseconds, it will just report a to be improved. If it's exceeding 500 milliseconds, it's poor. And that can easily happen if you have a lot of tracking going on your app. It's already hard to have a good spot without third parties. Adding them on top makes the game just even harder and sometimes just not even doable at all. So yeah, breaking down INP, it has 3 stages. We only want to talk about this here at the moment. processing time. So it has a time before, it has a time after, but this is the thing we are actually want to talk about today. So some words about the endboss I've mentioned a couple of times, the Google Tag Manager, also AKA GTM. GTM, yeah, as I said before, it's the puppeteer. So you can say it's a portal where you can say, okay, the user hit our page and then some event passes in and then I want to download Bing and then Twitter and then Google Ads and then whatever. And then when he logs in, I send another request, and after they logged in, I want to have some A/B testing to test different login styles or whatever. And all of this is happening in Google Tag Manager. And you as a developer have no clue about it at all, because this is happening in some portal where only marketing teams have access to and not you. And that's not good. How is it working in the background though? Because that's very important. In the background, it spawns an object that is called data layer. It's just an array on the window object. And here in this area, this one here, where the magic with the wizards always do magic. So here in this part, it overrides, so it monkey patches the push method. So whenever you from the client say data layer.push, GTM gets activated, reads the event data, and then does whatever magic it wants to do. This is how it works. So I've talked about being the performance doctor. Let's talk about the therapy. We now know about third parties are bad and they hurt, and it's an illness and not an illness that is like very unique. Most of us have it. So let's cure it. So the doctor says, and don't worry, poor app, I have a cure for you. Seriously, don't worry. It's called Partytown. Funny name, but it will make sense in a while. But it's a little bit experimental, so you might want to take this monkey patch as a first treatment. So that's why we knew already, when we want to introduce this thing into an enterprise application, we will have a hard time. So we try to think about something that can bring benefits, but without like destroying everything. So we went with this data layer monkey patch. I've told you about monkey patching before. That's why I showed you how Google Tag Manager does it. And we said, okay, we can do the same thing. We be smart, and we just schedule the tracking thing away from our click event listeners, for example. So in the end, our NP will be beautifully fast, and we just have a timer that expires at some point, and then we execute tracking. Everything is good. Measurements are great. How can we do that? Very simple, like the GTM does itself internally. We again override the data layer.push method and again like override its functionality, call the original function, but instead of just calling it, we use schedule idle callback and say, okay, you just run whenever the browser has time for it to run. Very simple trick, very cool. And here's the data that proves how cool it is. So we introduced this exact monkey patch in a $1 billion application, and this is the number, those are the numbers we got out of it. So you see from P10, this is the INP value, so interaction to next paint, how fast it is to track users' interactions. You can see immediately all of the measurements, like 10th percentile until 59th percentile, all of them got improved brutally. You see, for example, P75 is reduced by 312 milliseconds, and it went from very bad to okay-ish. It a little bit decreases on the P59th percentile, and it makes sense because those devices are so slow that if you pollute just the whole main thread for them, there's no chance the browser can at any way have an idle window. So you always have scripts to execute. That's why it peaked at P75 and it went down at P95. But that's where we care about most, because they have a horrible experience on our webpage. Look at it. It's like over 1 second INP. That means whenever you interact with the page, you have to exactly wait 1 second until you see a new frame. That's like, you cannot even imagine how hard it is. But anyway, we got brutal and really good improvements. Just look at this here. Good events. Good events went up from 40% to 60%. 20% increase in good events is decent for just this tiny change. So you can also use it for logging, by the way, the same hack. We don't have to go over all the lines of codes here, but essentially what's happening here in the bottom is we override again the data layer.push method, but instead of doing some extra special thing, we just calculate the time it takes in order to compute this and log it into the console. And then we can see, for example, track event took 120 milliseconds, content view took 166 milliseconds, track event took 81 milliseconds, and this is how you can actually read in the console like how long it takes for your CPU to actually compute the tracking events. And if I just see 150 milliseconds spent on only sending data to some whatever server, like it's ridiculous. We shouldn't do that. We just shouldn't do that. So now I need to introduce you to partytown. So the doctor is here again, and he says, are you ready for the actual treatment now? Let me introduce you to the web worker. The web worker is one hell of a web API. And it says, don't worry, poor app, I'm going to help you out. So what does a web worker do? A web worker essentially, just by giving this graphic, here is the original state. You have a main thread and you execute work and other work. The worker thread actually is able to give you true multi-threading to single-threaded JavaScript applications. So you have another thread here and you can execute work in parallel. I have to do it in quotes because it's not really in parallel, but it is in parallel. So it's gone from the main thread. Whatever happens here is not really touching your user interface anymore. It's gone. It's somewhere else, computed on another CPU layer you don't care about anymore. So how do you create workers? Very straightforward, actually. You just have a JavaScript file and you say, hey, this JavaScript file is now a new worker. That's JavaScript. No library needed for this. But you see this log function here. How can we execute it? Because now we have this worker, it has a log method in the background. How can we talk to it? It's not like we instantiate a class and then we can call its functions. No. Workers need to communicate through a messaging pipeline. That's why they are always asynchronous. Workers have also a different scope. They are not window, they are self. So they do not have really access to what is going on the window. This is crucial for third parties. They have access to the most JavaScript primitives and constructs, but like not all of them. They can do fetch APIs, but that's about it. There it kind of ends. So how do you communicate with a worker? On the top end, you just say, okay, I send a post message and I send some data. On the worker side, you say, okay, I have an event listener now to listen to those messages and then I can react to that. It also works vice versa, so you can communicate back from the worker to the main thread. But it always has to happen asynchronously. Another limitation for workers, and this is like the most fucked up one, they cannot really access the DOM, but it also makes sense. They run on a different thread. Of course they cannot read your DOM because your DOM is part of your main thread. So when you do this in a worker, it fails because document is not defined. If you do document.getElementById, it fails because you have no document. If you call navigator.sendBeacon, some like more exotic API, it fails, of course, because it has no access to it. If you want to print something that you have stored in your main thread on the window, it fails because it has no access to it. So that's a big problem. You cannot just put all of your third parties into a worker because they will like go crazy. They cannot do anything anymore. And you don't even know what they are doing. That's the biggest issue. I mean, you don't even know what they're doing. So the worker isn't equipped with the right tools. Now partytown comes into place and it provides some form of solution for it. So they have a thing that's called worker proxy. On the left side, you see the worker thread. On the right side, you see the main thread. So the worker thread now asks for document.title, as we did before. So it goes through the worker proxy. Worker proxy goes back to the main thread, asks for, hey, main thread, give me a document.title. and then it can give it the answer back to the worker thread. Sounds extremely simple. Let's get a little bit more complicated. Of course, I said before, it's always asynchronous, only one-sided though. It's only asynchronous for the main thread. It's never asynchronous for the worker thread. So, for example, you have a main thread. It says, okay, I want to track an event and send some message to the worker. At some point in time, and like literally there can happen minutes, because you have no idea about when the worker finally kicks in. It is so dependent on how busy is your device, how busy is your main thread, how busy is your worker thread with other stuff. So you have no control about timing. You send it and then you hope it's going to be executed at some point in time. We add another layer on top of it. It's the service worker that's sitting in between. So we have not only the web worker, but also the service worker. Don't like get confused by those two worker things. Web worker is the thing that's happening in another thread. Service worker is something extremely different. It's just sitting in between to have a communication layer between worker and main thread. So the worker thread actually sends an HTTP request to the main thread, and it's a synchronous one. It waits for the answer, and then it can continue working. If it wouldn't be synchronous, then, for example, you have a third-party script that says, give me document.title. If this would, for some reason, be asynchronous, the whole script would be like destroyed immediately. So it has to have a methodology to query the DOM, even if it takes for a long time, but it has to be sync. You cannot be async. Nothing else can be executed afterwards. This is why the worker proxy uses, let's call it forbidden technique. I'm not sure. It's deprecated on non-worker threads already. So if you open up a new XML HTTP request and pass false as third parameter, you will have a synchronous HTTP request. So this line here is only reached after you got a response on here. It's forbidden on the main thread because this can lead to like severe blocking problems in your application. But on worker threads, that's actually what we want. The worker wants to know document.title from the window, and it wants to wait until it got a response from it. It doesn't want to execute anything else until it got a response. So this is how it's working back scenes. So let's take this example here from before, but now we add a .title query here again, and then some GTM thing is going to happen. So in flame charts or in the execution context, it would look like this. And to reduce a little bit of complexity, let's fade out the things we already know about and only look at the stuff that is new. So now we added the network thread here, and you see this network call that is called partytown. This is how it's called when partytown wants to communicate back to the main thread. So we as a user click something, then some tracking happens in the worker thread, but wants to know document.title or a cookie or whatever is happening on the main thread. So it has to spin up this HTTP call back to the main thread, ask for data. That's where we execute here. We get the data back, receive it on the worker thread, can execute the rest of the code. Pretty cool. And all of this function here, it doesn't matter how long it takes until it's getting executed because you're on a background thread. This is not affecting your user interface. No one will be blocked. No one will notice. Maybe your fans spin up. Yeah, like you can notice your device is getting hotter and fans are getting louder, but UI is still in a top condition. And that's what we want. So how do we integrate this like extremely complex thing? Kind of easy. We do npm install build.io partytown, put this partytown.js script in our head tag. Then we want to define what of our third parties want to live in the partytown context. Then we say, okay, we download it just with the type text partytown. This is the thing we have to do. And then everything is working. You see like partytown sandbox is sending you, hey, I've created the web worker, and hey, I've created the window, and everything is cool. So the worker and the application lived happily ever after. I would have loved to tell you. Instead, it's not the case, and now the real story begins. We can give the name that hasn't have a name in the beginning. and it is bwin.com, so really large application. So this is the story, how we implemented or integrated partytown in this huge application with hundreds of thousands or millions of users a day. Do you remember the graphic content warning? So then let's do a live demo and take a look at how it actually looks like. I will switch now to my new browser window here, where I need to show you the real URL. It's called sports.bwin.de. I'm looking at the English language version here. Did some local tricks to disable all of the optimizations, because you can already guess in the end, like I will show you off how it looks like with the beautiful state. This is the non-beautiful state, however. So let's take a look. I will just do a performance recording and do some actions here. I will just select random bets and just put them into my bucket here. And it's unthrottled, so this is a high-performing device, very recent, very new, and you can see those black, those yellow walls here. And this is one of the things that are really concerning. b.push, this is the minified version of data layer.push, this is GTM, executing for 100 milliseconds on my unthrottled, like high-end laptop device right now, and this blocking, it's creating like 2 long tasks at once. And just imagine how you would end up with a device that is, I don't know, 5 years old and it's mobile. Then you have like 1.5 seconds here and your screen is frozen, like really frozen. You don't want that. You really don't want that. And it's like not a unique event. It's like happening here. Oh, it's happening here. Huh, it's happening here again. So for every interaction I do on the page, tracking is going completely crazy and blocking my main thread with execution I have no control over. And that's what we do not want, like really do not want. Okay, so poor app, are you ready for the first, like for your first injection? Let's try it out. Huh. Just integrating partytown as they state in the docs will result in, I don't know, a very frustrating state. Nothing is going to work. Most of the third parties will run into some form of errors. But well, you know, we knew already it's going to be experimental, so let's break it down. Course as the first thing, because that's the first thing that jumps actually into our minds. Course is an issue because the worker doesn't download scripts like this. What the worker actually does is it transforms your script type text partytown things into fetch statements. And fetch statements need to have access control, allow origin response headers, otherwise they will just respond with, I cannot answer you, it's like not secure, I'm very sorry. So this one here is totally fine, this one here can be really bad, depending on what third party you are actually querying for. Google Tag Manager, by the way, is totally fine because, yeah, of course they are. So it looks like you definitely need to have a reverse proxy. Very like ugly name, I hate it. I had a colleague once back in the time, whenever someone said reverse proxy, he would just hide below the table because he just like he was so anxious just because of reverse proxy. So let's break it down. Reverse proxy is really simple. There's just someone sitting in between of a network call that's pretending to be a web server, that's it. That's all of the magic. So in this case, there is a partytown configuration thing that's called resolve URL, and we say, okay, whenever you want to query for connect.facebook.net, then just use our reverse proxy URL, and that's about it. So you have to implement some form of reverse proxy on your end, or you can, of course, like host the third parties on your end. That's also going to work. But I think this is easier. There are like 10,000 different libraries that help you implementing reverse proxies on every different technology. We use the YARP for .NET. Works fine. Okay, so course issues are fixed. This should help. Let's go for another try. Deploy to beta, maybe. Maybe it's better. Yeah, we tried. Tracking team was really mad at us. Like, really. No data anymore. Okay, so we were confused and running around the room like chicken, and where's the tracking gone? But then we got new like power and said, okay, it cannot be that hard. One eternity later, really one eternity later, we debugged the freaking minified GTM.js code that was shipped via URLs you cannot imagine. It was bad, really bad. This is the code we actually debugged, and it was no fun. It took us several days to figure out that at one point, this GTM.js, this is very important for Google Tag Manager, very important event. If this doesn't fire, nothing is going to execute. So we were searching for this, and we could find it in the data layer at some point, but next breakpoint, window data layer, was replaced with something else, and we had no idea why. Until we finally figured out some of those scripts were accessing global. And partytown said, okay, hey, I know the type of global. It's window, right? Haha, I can give you a new window. Okay, new window, new data layer object, everything is gone. Yeah, so cool. So in the end, we ended up to just monkey patch the freaking global property with just document in the worker thread. So we had, like, this is literally the code we injected into our app. It looks stupid, but this is the code. It fixes the problem. Really cool. However, there were still events missing. And now we need to talk about event forwarding, like how a worker and main thread communicate to each other. So it's not only possible that you configure click event trackings from the GTM console, you can also trigger data layer push events from your main thread application. And that's what we did. We had a track event thing, and we said window data layer.push and send some event. And we wanted to GTM react to it and then download more stuff or send events to analytics or whatever it does. However, if you do that on the main thread here, so you have this array, and on the worker you have another array, two different arrays. You push here from the main thread to an array that's only available in the main thread, the worker has no idea about it. Like really no idea. Partytown is smart enough to provide a configuration for that, so you can say, okay, data layer.push is something we want to forward from main thread to worker thread. So whenever this happens, just create a message and send it to the worker. And then if you do data layer.push from the main thread, it will also end up in the worker thread. That's super cool. However, we were still missing events. Turns out there is something, for example, Bing.com, Bing Analytics, just says this. This is the script of Bing Analytics, just with some code here in between the lines. They do not window.something equals. They just do, okay, those are my functions, put them to the window context. Worker has no clue, of course. So GTM.js in the worker thread asks for, hey, I want to execute this init function because I know I should do it on certain tags, but it's not there. What can you do? You can configure partytown to let global functions that were not added specifically via window.whatever to the window scope. That fixes it. We got more events and more third parties. That means more errors. There's another configuration that calls run scripts on main thread, and it does exactly what it says. So failing scripts that you know, for example, they are mini apps like a chatbot. Third party that opens up this chat window thingy where you can reply to chatbots, whatever. They create a lot of DOM, essentially a mini app, micro front end. You can call it like that. If you have something like that, don't execute it in the worker. It just will be horrible. Just put it into the main thread with this command. You're good to go. Whew. Okay, after all this trouble, we are good now, right? Let's deploy to production, just to be sure that we are good now. Hey, doctor, I'm not sure what it is, but something is missing. And you can see the reaction. Like this is like how we actually felt, melting face. Okay, next issue. Next issue. We're analyzing tracking events now, very deep. We are on the page Hub Olympics. What tracking says is we are on the page EN Sports. Doesn't sound right. The worker, of course, has no clue about soft navigations. So what we can do is use what we know now, like the event forwarding, the monkey patching, and create our very own monkey patch for the location. That's so beautiful. So we create a proxy object, PT, partytown, worker location, and give it a set method that we can call from the main thread then. Then we store a little variable for the application that we afterwards can reuse to give it to the worker. And we need to react here in the set method to set the new, for example, href. This is very simplified, this solution. Finally, we need to just, in the worker thread, text partytown, very important, in the worker thread, override the getter for location and say, okay, instead of giving me whatever you wanted to give me the new one, the monkey patched one, okay? And then finally, we have to configure a forward for pt worker location.set to get the messaging channel going on. Of course, from the main thread, and this is Angular application now, we inject our router. Whenever we have a new router event, we give the worker the information by setting window.pt worker location new window location ref whenever a navigation event happened. Cool. Good result. Location URL, Hub Olympics, referrer, also very good. Really nice. So that's way better now, but of course it has to happen. Of course it has to happen every time. Every time it has to happen. Some weird looking browser, like this dude here, complains that it's broken. Yeah. Don't have to tell you more. This is how I felt, seriously. And this is how it looked. It's even worse. But also, it has a funny reason, so I want to explain. This is what's happening in the worker proxy, where partytown creates all of the DOM APIs, and it needs to have a way to serialize DOM nodes that come from the main thread and you want to create, for example, in the worker. So what it stores is this node constructors map to node name. So if you send diff, then node constructors to diff will give you an actual constructor function. If you have this here, this little dash symbol, it means you have a custom element. So for example, my component, a component that you have customly created, because there are no default elements that have a dash. That's why they have this condition there. And whenever they have this dash, they want to fall back to unknown. Well, how do they come to unknown? This is the interesting part now. They iterate over window object properties. And this is not hosted anywhere. It's happening on your client. So when you browse with Safari to it, it will browse Safari object properties. If you browse with Chrome to it, it will browse Chrome properties, of course. And turns out that Safari has just a different ordering of elements. Chrome has HTML unknown element with the unknown tag as the very first element in the array. However, Safari has directory as the very first element in the array. That's causing the lookup to the unknown element to fail because it's not part of the array of the map. Instead, it's directory what is stored for Safari. And this call here, node name includes dash node unknown, will result in this very error. So yeah, that's why we put up a PR to partytown to fix that. That's how we got actual contributors to this library. So we're coming to an end now. Are you actually feeling better now for bwin? Let's do a live demo and take a look at how good we feel now. Just remember this picture here. Yellow bar, yellow bar, yellow bar, yellow bar, yellow bar. I will go to the next browser here. Let me quickly confirm that everything is up and running. You see those, this is actually interesting. You see those proxytown calls here? It's polluting your network tab. So you see it's already 8,000 requests I have just in idle. That's because third parties are requesting the main thread back and forth. But this is the confirmation, so I'm good to go. Partytown is running here. In case someone doesn't trust me, it's again sports.bwin.de. I'm not tricking you. Main window again. Performance. And now please, dear God, let me have some nice looking flame charts. It's loading the profile. I misclicked and did a navigation in between. I didn't want to. But oh boy, this is looking good. Look at this. There is no yellow. All of those red things here, this is really important. The red thing here, those here, they are not happening on the main thread. Because the main thread, you can see here, nothing is happening on the main thread. Like literally nothing is happening on the main thread. Where is the work happening? Ah, there's a worker thread. There the work is happening on the worker thread. It's not interfering with our UI anymore. Like it's gone. It's gone, happening on some other thread, spinning up my fans. I don't care. My user experience is great. This is what we want. Real world measurements. You remember that we already dipped this by 20%, and we dipped it again by 20%. Good events again by 20%. So with partytown, without the improvements from before, we would have seen 40% improvement here. This is so insane. After introducing partytown, we have 81% of good INP events on a website that is used by millions of people. This is like, I have never seen that before in my entire life. This is so crazy. This is so crazy and so crazy good. Look at P95. Look at P95. Those low-end devices, the devices that really suffer brutally from those tracking events, they're cured. They're not even bad anymore. And they paid like 200 euros for their phones, not 1,500 like we do. So yeah, full configuration. Forward, resolve URL, global functions, run script on main thread. Have the global thing in mind. And don't forget about the location monkey badge I forgot here on this slide. And if they didn't die, they're still configuring partytown until today. Special thanks. Special thanks before we end the session. Special thanks to a company called Entain and a person who's called Stephen Jaina, who's already also sitting here right now, who's our manager at Entain, who let me present you bwin.com and all those live data and all of those live things. So he made the whole talk possible. They are hiring Angular developers. Whoever is looking for a job, please, like reach out to him. Reach out to him. This is one of the coolest companies ever. He will be the best, for sure the best manager you have ever seen. Really cool person. Steve, don't get blushed, it's true. Seriously.
You forgot handsome.
My name is Julian Jandl. You know that already. I'm working for Pushbase. You know that also. Standing here, by the way. We do performance consulting, for example. You can book us. This is the end. Thank you so much for your attention. And Stephen, I can give you just you can talk and hire.
What a ride. Let's talk about partytown.
Please do it.
How many questions do we have? Or should we first go back and talk about the handsomeness scale of Stephen? How would you rate Stephen on a sexiness scale from 1 to 10? Okay, let's go to the questions. Who has the first question? One question here. Perfect. Take it.
So maybe no big question, but can you use partytown for estimation of performance for website without access to source code? So just if you know address of website.
Estimation?
Yeah.
What do you mean? Like use partytown to estimate?
So you know the address of website and that's it.
Yes, we could estimate what partytown would bring you for a benefit. Yes, definitely.
Okay.
I mean, that's actually not so complex because you just activated an ad blocker.
You can also book performance
use that. Basically, a estimation is just block the.
Yeah, like block them. See how it would perform if you don't have it.
I have a question about the performance engineering career that you are doing. I want to know that you were doing debugging on a production deployment, right, for the Bevin?
Yeah.
And how is it possible?
Yes.
That's a good
answer. Yeah, please.
I'm also looking for internships.
So it's very easy, right? So this stuff is hard. It really is. There's no kidding, and the payoff is huge. But you know what? We put it through every bit of QA ever, and it really isn't until you hit the volumes, and we're talking like millions of users a day, that you start noticing. And Julian will tell you that sometimes it takes us weeks to see, okay, we've had a drop in tracking, because it's not necessarily like super obvious. The errors don't necessarily scream at you. And then you have to go back and look. And so what I would say is it's super complicated, but the payoff is vast. And for us as an organization, we always have to trade that off, because if I was super conservative, this would have never have seen the light of day. It's as simple as that. And so you almost have to accept that, you might break something, but, we're so focused on our player experience that our players, frankly, don't care about tracking. There's no other way of putting it. It's the commercial teams that really do. And so I'd rather have a better player experience, and maybe I break tracking a little bit, than have an awful player experience. And that's what it boils down to.
I would like to ask if there is, so if there are multiple events, and like the events like as fast that like a double click and so on. So some of the trackers actually care about, was it, I don't know, some sort of user interaction like scrolling, double click, single click. But if the double click actually happens as fast that the worker is not yet ready with the task, is it queued, or is it?
Yes, it's delayed for a time we cannot control. So whenever your worker, and it's fully depending on your device, how many threads you have. If you have like 12 core CPU, then it's easier to put some work onto the worker compared to you have just a 2-core CPU, where you have just this one other thread where you can actually work on. So this is highly dependent on what device, and you from a front-end perspective cannot control it whatsoever. What I can show you now, maybe that answers your question, here in the thread of the worker. Here you can see it maybe really clearly. It's blocking for a total amount of 5 seconds, so it doesn't care at all. It just coalesces all of the events together that happened that the main thread sent to it, and then executing everything as soon as it has time for it at once. And then, I don't know, there's no event anymore, so it waits, and then the same thing can happen again, but you have no control over it.
Is it also possible to work this magic of partytown if your app is PWA or uses service worker in some other way?
Yeah, sure. There's like no complication. It doesn't compete with.
Because I noticed that the worker actually uses the service worker as well for the communication.
Yes, I mean, there's so much more to talk about partytown. I just scratched the surface actually. For this service worker communication is actually the old one. That's the fallback. There's a new one that's called Atomics that promises 10 times faster communication between main thread and worker thread without the network traffic going on. Mm-hmm. And you won't see your network tab polluted by proxytown so hard. Yeah, but it should work fine. I don't see any situation where it could break each other. should integrate just fine.
Maybe if you try and find out it doesn't work, let me know.
What come again?
Maybe if you try and find out that it doesn't work somehow or interferes, just let me know.
I will for sure.
Okay.
I remember there was an issue with Angular.
Take the microphone. Or the, what is it called? The pen flip?
Yeah. So there was an issue where you had to actually merge the service workers if you use the Angular PVA. Like there was this other huge company we tried the partytown like years ago.
We had that issue?
Yeah, we had that. Maybe that's why Marek is asking, because he remembers. Yeah, it's now solved, I would say. You have to merge the service workers. But then it affects the communication again. It's not that bad.
I mean, the service worker doesn't have such a brutal job. The work.
It's not the biggest problem.
It's confusing because you have service worker and worker. So the web worker is actually executing the stuff. The service worker, you can see it here. This is the service worker thread. It actually doesn't do so much stuff. It does clone and JSON. Clone and JSON all over the place. So it's only like there for like, okay, give me data, I send you data. Give me data, I send you data. That's it.
Yeah.
It's not executing anything.
I would say having these two service worker merged is your least problem when dealing with partytown.
More questions?
No, I have a question for, I mean, Google Analytics, Google Tag Manager is not an exotic tool, so it's used by like millions.
Yeah.
So why is the performance of it kind of still so, I mean, this should be a known problem which other companies have as well. Why don't they provide a better solution for it, for such a fastly popular product?
Because it's hard. GTM is just a mechanism to download other third parties. Like it's an event bus. They get an event like you here in bwin, for example. I click on this here. So I placed now a bet. And then what happens in GTM, it gets this custom event and the marketing team can say, okay, when a user placed a bet, then on this trigger I can react to, and if it happened 10 times, then I can send whatever. It's just a portal where people can, where developers, marketing developers I would call them, like set up this container thing and say, okay, this event happens, then a chain of other events should happen. And if GTM would do this thing and put stuff into the worker, they would probably break 59% of the world. I don't know. They cannot do it. What they did, by the way, and I didn't really spoke about that, but that's what I mentioned. That's what I noticed today, and really today the first time. Usually, the b.push event would be here, even before the actual pick click is something that's happening in bwin.com. Actually, before they updated their software, tracking would have happened here before. But now they did something, and now tracking is executed here, and it's not even some timer, it's an idle callback what's executed here. And this is what Google did to improve the performance. That's what I introduced in the like as a monkey patch. What we did, we tried to patch on top the data layer.push method and try to execute the work on an idle callback. And now Google just also did it.
Good. Okay.
I just want to ask about other tools. Like you had so much trouble with Tag Manager, probably because you said that was the end boss, but is it so hard for the others also? So for example, if you have multiple Google Analytics, Sentry, and the other things are on your web page, you also need to go through the check what's really going on in the background to use this partytown, or maybe it will be more simple for...
No, it's not simple at all. You have to like enable it, see what's erroring out, hope, you can then only hope that nothing is erroring out like silently. For example, this one here, UIT init, this, now I'm going wrong direction. Here, this UIT init here, this is Bing tracking. It failed, it errored out, and it didn't tell us until we figured out it's missing this configuration. So this is really...
And how did you realize that that's missing?
Debugging minified third-party scripts for days.
Thank you.
No fun at all. I would not recommend. 0 of 10.
The flame chart and the first paint is a very technical metric. How do you present the users the massive performance win?
Easy. Like this.
With this. With the first paint.
This is the tables we present regularly to Stephen. Like they do not really always look that beautiful, but if they do, we are really proud of them. But this is, I just said INP, bwin.com, INP sportingbet.com, so 2 different labels. But we, of course, report more metrics, and those are not like, we measure them on our devices. Those are measured on, I don't know, Impulse or Crux or something like that.
And I have to say they always look that beautiful.
Most of the time.
And I can tell you what else we take videos of the scene and slow them down because you know with an SPA how difficult it is to consistently measure when a navigation starts and finishes. So what these guys perhaps don't realize is I take videos and I slow them down, and that's how I present it. And you can see that the navigation, you tap, you see the interaction, and the next page comes up. And there's a difference, and that's what we want. Right? We want the next page to come up more. And frankly, the state of STA, now stops that traffic, which is like, video, self-video.
Good point, thanks, yeah. Visuals. Yeah, visuals are always great to get the point. Michael, there's one question like hanging forever.
So, what was also pretty important is that the GTM tracking that you see with the data layer push, it's actually the custom events. Like you configure the custom event, and that is what is slow, and it depends on the serialization that is going on inside.
Yeah.
So it's also not the same length of milliseconds every time. Sometimes, when you put a lot of things into your betting basket, it could take seconds, the serialization of all of the data. So it's not really like navigation and basic events you have on GA4 or GA3. It's really the custom events that are the problem on.
Yeah, it's the amount that is configured on the specific application. That's why we also see different numbers here. Like for Sporting Bet 600, for bwin only 500 milliseconds.
And that's also related to the Sentry question, or the overall speed that you see when you extract the things. Because once you get the blocking serializations that are happening right when you click, when they don't have to, suddenly, everything is much snappier because you have like 80 milliseconds of window where your browser is idling.
Your browser's telling you something, yeah.
One more question here.
Just is there some approach for time-sensitive tracking or demands with time-sensitive tracking, or you just exclude them?
Really hard, because that's an issue we are also facing right now. Let me quickly find the slide here. Run scripts on main thread. I think this is, you have to opt out on this very place. It doesn't always work. So if everything comes via GTM, then some scripts are really depending on GTM. So if you just put them into the main thread, they lose their communication layer. That's what you then have to configure manually back. Or you just don't inject them via GTM and just inject them like a regular third party with script tag, whatever, in the head.
Yeah.
But if there's something you click and it has to happen on click,
Better enough.
worker is not your choice.
Okay.
Definitely.
Thanks.
One more question or two? No? Not a second?
Why is it called partytown?
That's easy. That's easy. It's easy. It's a town for third parties. Ah! Ding. It's easy. It's a town for third parties.
It's called proxy town.
I don't know.
It's a proxy for the party town.
Okay.
Okay, so enough questions. Let's go to the final. I don't need a microphone anymore. Let's save the battery. Let's go to the final part of the evening.
What do you want in the background? This?
Our slide with the,
Yeah,
with
this
the
one.
prices.
We have. Where do I find it?
Conference tickets for NGDE, massively cool. Many of today's speakers will be also presented here. Yes. A JetBrains license yearly for any single JetBrains product that you want. Doesn't have to be WebStorm, can be Kai, whatever, Titan, Go, Storm, I don't know how they call it. A second one, yearly license for whatever you want. And a handful of t-shirts, I would say 5.
Boah, ich habe auch so ein Ding.
We always need a luck to pull from our bowl.